All right, let's do some work for the next 4 hours. And first, a little update. So this weekend I went to the K-Scale. If you don't know K-Scale, we talked about K-Scale before. Kscale.dev. It's a website. They make humanoid robots. They're a YC company. You can pre-order a K-Bot today. It's like 20K for a full scale humanoid. You can finance it. What's cool, other than like the humanoid, the hardware itself, they also have a bunch of open source stuff. The hardware is open source, but they also have a lot of software, cool software, including this thing called K-Lang, which is natural language to action of the humanoid. So they're also developing that. So you can buy this humanoid, tell it to do something, and it'll do it, kind of thing. Obviously, it's not quite there yet, but that's where it's headed. Anyways, these guys threw a hackathon and I got to work on their Zeroth bot. Zeroth bot. I always call it Zeroth, but it's like this smaller guy, and it's like there's I tweeted about it. Did some like mapping human motion and translating it to robot motion using a camera. It was cool. We had a bit of an Olympics event. We played soccer and stuff like that. It was cool. Yeah, we boxed, we danced, and we won a robot. So now I have another robot here. But I really need to focus on the quadruped. So today's part 13. I kind of push all the hardware mechanical stuff to part 14 in the future. Just kind of like don't feel like doing it right now. I guess the other cool, like I'll just add here some links, right? So cool things. The cool thing about this Zeroth bot here is that, and I don't think they've publicly announced this. They mentioned it on the hackathon. It's like you're gonna be able to buy one of these guys for like $300 in January from them. They're working on a sheet metal version. They're producing thousands of them. So I think that's it's a small humanoid like this size. But it's so cheap, it's so accessible, and their SDK is pretty good. So I think that's very exciting. So I would keep an eye out for that. And they're throwing another hackathon in January. If you join their Discord, you'll see it. Which again, I would also go to that. It's pretty cool. At the hackathon, I got to meet some people from Hugging Face. They talk about Le Robot. I haven't fully grasped what Le Robot is, but it looks like it's a framework to deploy, AI models in robotics pretty quickly. And they also talked about their arms. So they have these SO100 arm. Where is it? This guy. Looks like you can 3D print this arm and buy parts for it, and it's total 241. It's pretty cheap. Well, actually, is that so? Yeah, so pretty cheap. So I'll put these links here in the description. At that price, I'm like kind of tempted to build one. And they also have some examples on like how to deploy a model with it, some Aloha model. So I thought that was pretty cool. I see a lot of hype around robot arms now. It's like every application, at least here in the Bay Area, every company, every hardware company, that has a problem, if it's a robot that vacuums your house, okay, but it has an arm so you can pick up things. Like a robot that cleans the street, but it has an arm to pick up things in the street. A robot that cleans toilets, like Roomba for your toilet, but it has arms so you can clean the, or a robot that cooks with arms. Everything has arms, and all of these startups are building on open source hardware. So I think that's interesting, and I it's like a more strategic, it would be way more strategic for me to be working on arms than like building a robot dog. I saw the Disney paper first, and I was more interested in that. But now I feel like, you could probably build somewhat of a business selling these robot arms, right? Because a lot of them are building on the open source hardware, but probably not all of them want to like 3D print their own parts and assemble all the stuff. You could probably get like 100%, 200% margin if you sell pre-assembled units, right? Like, and you ship them fast. So that's interesting. And it's also probably a good skill to have, right? If you're looking for a job, if you're an engineer, you're looking for a job, get familiar with arms, and you probably won't have any issues getting a job. And then the last thing I'll put here is this TED Talk from Jeff Bezos from 2003, like a lifetime ago, where he speaks about how electricity and how the internet is the new electricity, and how it's gonna get everywhere, and how people didn't want to put electricity in their house; they wanted light bulbs in their house, and of course that requires electricity. But it was light was kind of like the application that drove electricity adoption. He makes a metaphor for the internet that was 20 years ago, 21 years ago. You could use the same metaphor today for AI, and so just recommend watching that. But anyways, what we're gonna do today is I guess I want to say one more thing. I put out my YC application out here. Anyone can see it. I thought it was good to build in public. There's a lot of hate here, a lot of anonymous hate comments. That's fine, In general, I've always thought haters just hate themselves more than they hate you. But I'm just my ask is, if you're gonna hate, just don't do it as an anonymous. Actually, let's have a discussion about these. Your anonymous comments are not gonna make anyone change their mind. So there were a lot of nice people left actual comments with their face and their name. That's great. And then some people left hate with no name and no face and just anonymous. Please leave your name. Don't be a coward. All right. So these are kind of to-do things that I laid down on the last video, and for context, that was kind of a week ago. It's been a while. The last video was, of course, training teaching a 2D model, teaching a model how to work on a 2D environment using the OpenAI Gymnasium, or just Gymnasium. It's not by OpenAI anymore. And trying different algorithms, PPO, TD3, SAC, A2C, in SB3. And it kind of worked okay. One of the things that I didn't mention was how do you know if your results are good, right? Obviously, if you're doing something for the first time, you cannot have to be the judge. Does it meet your expectations? But I think the beauty of when you use something like Gymnasium is that, hey, these are standard environments that a lot of people have had access to and a lot of people have done work on. So you can kind of there's this leaderboard that OpenAI used to maintain. I don't know if this is up to date anymore. But for example, here you can say, the link is here also under. I'll put it under cool things here, so you can go watch it. And the link to all this entire document is in this video description. But you can see, for example, for the bipedal walker B2 or B3, I guess, you can see the results of some people had. First of all, episodes before solved, 28, 40, 57, right? Just as a reminder, I was doing 3 million time steps, right? 3 million time steps. And then each episode was around 1,600 time steps. So that's 2,000 episodes. This guy solved it in 28. And then if you can watch their video, and actually it's pretty good, it's not bad, it's good. And then what's most interesting is, there's a write-up on how they got these results, and of course it's more complex than, hey, I opened CV3 and chose PPO and just let it rip, right? It's a little more complex. So it's a good way to learn. Except I guess the other thing was I actually think it's kind of lame to learn on examples. Just learn by doing what you actually want to do. I should have gone straight to 3D and just trying to figure that out, but I didn't, so bit of some regrets there. Anyway, so this is what I was planning to do today. Import robot to MuJoCo, attempt to train. Okay, so there's two things here. A bunch of them are in OnShape and the rest are not in OnShape. So we can do this. We can rerun the experiment with two different algos and more time steps, right? Because I think the last time we said that Some of them were still needed more time. Actually, I remember we wrote the results here. I can't see the Christmas tree. Yeah, so for I think A to C was sorry, experiment 2, right? So we started removing some sensors from our observation space. Looks like we ended it prematurely at 3 million time steps, right? So we shouldn't cap it. So we should rerun these with more time steps using an SAC algo. The other thing I was gonna say here was, so I was talking about this idea of like removing parts of the observation space that's standard from gymnasium because we don't have those sensors in real life, and apparently there's a whole technique of training with more data in simulation than you have in real life, and then deploying that model in real life with the limited sensors you have, and apparently that can yield good results. And I don't know exactly how you deploy that, how you manage having less inputs into the agent, but we can explore that as a concept that appears to be doable. Yeah. So let's see where we're at here. Step Antarctic. Oh. Antarctic cursor. All right, so this is what we had last time. A bunch of terminals. I'm just gonna close them. All right, so bipedal, tops versus flops, troubleshooting, and all of this is publicly available. Bipedal, right? So bipedal, this was just an example of how to load the environment. I'm just gonna write this here. Example code on how to open the bipedal. Yeah, that's it. All right, and then SB3, that's when we started doing more involved things, and we had experiment 2. Experiment 2 was the one where we removed the most stuff from the observation space, and we said it would have been good to keep going more than 3 million time steps. But before we just run it again, we should, so I'm gonna put this down here. We should improve the RL training pipeline. So infinite time run, no constraint time steps, and save models every eval callback. And the reason for that is we need to be able to evaluate different models and not just the best model, right? Because like we're getting best model based on, I think, only absolute reward, but not, there were like better models if we looked at absolute reward plus episode length. Yeah, so infinite time, no constraints, save model, and every callback. All right, and so for that, we can look at, I guess we'll start a new folder, we'll call it experiment 3, and I guess what matters here is, I guess I'm gonna copy all of this stuff here and close these. What matters here, okay, so we remove the following observations. Okay, this is the same as experiment 2, but with an improved training pipeline to allow for more time steps and better callbacks. Basically that, and then we have the 2 files here that defined how we train things. And hold on, I'm gonna get a drink. All right, so 2 files, evaluate and train, right? So we have the evaluate and the other one that says nothing, that's the training one. So evaluation basically means opening the results and observing them. And you basically run this file and tell them which algorithm you're interested in and what checkpoint. I don't think we need to make any changes to this. But on this one here, these are our actual training file. You know, parameters, those are not going to change. So we're going to say, I want to change these so we don't only save the best model, but actually save the model at every, I think evaluation callback is what we eval at every eval callback, such that it can be evaluated after. All right. I don't know why we need a custom observation wrapper. Make environment, EC, get algorithm parameters, yes, EC, train model. Okay, I think that looks good to me. Why do we need custom observation wrapper? Oh, I see, true. Yeah, custom observation wrapper is how we remove things from the observation space, I think. Yeah. Right. Yeah, okay. Will the new saved checkpoints work with evaluate by pedal? Oh, connection failed. Yeah, so just making sure our evaluate function will still work. But the evaluation script is looking model when using it. Let's modify. All right, so let's try running these and see what happens. Oh, also, I guess the other thing would be, how do I open TensorBoard? I always forget how to open TensorBoard, so can we just write something for that? Can we automatically open TensorBoard when executing our bipedal SV3 Pi? Yeah, I think that makes sense. Let's see how that plays out. Let's try it. Okay. All right, so if I remember this correctly, so we can go from here to experiment 3, and then we can do Python bipedal SB3 Pi, and then do like, did we say what was experiment 2? SAC. So I'll go SAC time steps 100 million, and executing this should automatically also run TensorBoard. it did not run TensorBoard. But it is training. Maybe we need to manually open the. Nope. Alright, let's try this. Yep. So that worked. All right. So this is what we just kicked off here, and we care about eval here. And so I think we're saving every 10,000. So by now we should have one saved, and you know, obviously it just started. I just want to make sure there's gonna be another one saved at 20,000 here, and so you can look at our progress. We are getting close. We're at 20,000 steps here. All right, there we go. So the second data point here. Now we have a line, and now in theory, we can open these different. We can go to our eval. We can go to our evaluate here, and this will take an algorithm, right? So SAC, I think, yeah. Model path, no model, checkpoint. All right, so we can let's try it. Well, actually, let's look at just the file structure. Will tell us. Yeah, you can see. All right, so we can see, for example, so Python evaluate bipedal py algo SAC checkpoint 10,000. Oh, yeah. All right, and it's terrible. It's the first one. Reward, yeah, that works. Cool. That's cool. All right, so we can let this run for a while. Let's go here. Infinite time run. No constraint on time steps. Not needed. Just specify a very high number. Done. And done. Done. I guess the other thing is we said we will try different algos, so we can do that too. So just let me check the. Let me check that we're just making sure we're not frying anything. Yeah, should be fine. All right, so here, let's run it. Let's open a couple more terminals, and then let's do the same thing. Right, so it's SB through pi, algo PPO, time steps. Right, so that kicks that off, and then the next one. TD3, I think we said TD3, algo. All right. Let's see if TensorBoard updates. Yes, it did. Should be a TD3 here somewhere soon. Skip it. Yep, there you go. All right. Now this is gonna take a while. It's not gonna be super fast, but it's underway. So I'm gonna set this as done. And so the next thing would be to import robot to MuJoCo. And for that, we also had something, right? So, all right. So last time we were looking at, this is what we were talking about, K-scale. It was like MuJoCo to URDF. So K-scale has a onShape to URDF function here, and actually it says onShape to URDF, but it's actually onShape to URDF plus MuJoCo in a single go. The only catch, and it's not really a catch, is that you do have to follow a specific file convention. So your assembly on onShape has to be formatted a certain way. So I had a basic example. Trying to remember, but I had a very basic example here. Okay, so this is okay. So let me comment these files. But this was me attempting to make a file, example code on how to open a MuJoCo, open a custom model in Gymnasium. Sorry, what is Walker 2D v5? There's nothing custom here anyways. And then I had this file called onShape. I'm just trying to remember what everything means here. Instructions. First run onShape to robot. Was that it? I don't know. Pi. Oh, okay. So this was yes. This was an example code on how to open a custom model in Gymnasium. Now I remember. This is nothing really. This could be deleted. This can be deleted. All right. So we had this file called MJCF to MJCF is the file required for the format required for MuJoCo. It's kind of like equivalent to URDF, but formatted for MuJoCo. And then we had onShape to URDF. I will try using this library. I remember trying using that library. I found this tutorial. Yes. So this is a way, but that was the old way. So I'm gonna create archive, and I'm put a onShape to URDF. I'm gonna put that here in archive. That's the old way. We don't do that anymore. URDF to MJCF. I don't think we need that anymore because, like I said, like I said, the K-scale stuff takes care of this stuff. Yeah, URDF to MuJoCo. Also don't need that because we're not doing URDF to MuJoCo. We're going onShape straight to URDF to MuJoCo. All right. So we have an env. Oh my god, I should not have shown that. These are my onShape keys. Hopefully I'll remember to blank this out. Instructions. First run onShape robot directory. Okay, so let me read. So let's see the instructions from K-scale here, right? So this library is okay. Pip install. Obviously I did this last time, right? So you can just verify by going which K-scale. Oh, not found. That's odd. Install again. I might have been in a different environment. Oh, actually it's already installed. This library, yes. Here's an example. Okay. To reproduce a you can run the following. Okay. Install, yes. I'm sure I've done all of that. All right. Yeah, so you go on your CL on your terminal and you run call run and a link to your on shape. And you can do post-process also, but if you just do run, it downloads and does post-process. I don't know why you want to break it apart. I don't know what PyBullet does. The output of the Onshape library is simply a robot floating in space. Okay, there you go. So you can kind of like visualize it. Luckily, most simulators which support URDF are able to define an environment within code. That's correct. More changes are needed to make MJCF files simulation ready. Oh, really? All right, so this last line, it's kind of worrisome. I thought they were already simulation ready. I wish they would say why they're not simulation ready. Anyways, then I went to Onshape. Actually, I'm gonna change this to a live theme. Then I went to Onshape, and because I wasn't sure what's the right formatting, I made a very basic example called MuJoCo experiment. And so I think, you know, this has two parts, one mate, Robotics mate. And so basically you can do, the way I understand it at least, first import. Sorry, I'm just gonna delete files here. I'm gonna delete this guy. Gonna move this guy here. You can do call, run, and the link to. In order to choose, you must first set your API key. No. Okay. I need to export my keys from the environment variable. How do I export my keys or define them? They are in .env. My API keys. Basically, I have my keys in an environment file, and it's like, okay. So, is there a command for these? I wonder if this will work. Nope. Echo. Can I just apply to export everything in .m? Something like that. This is a pretty rookie mistake, I think. I feel like that was not it. Okay, let me try this again. Yes, okay, now it works. I'm gonna also put this in archive. Whoa, no. Maybe things to the archive. Where were we? Anyway, so run that and created this new file called robot. You can't see my face in the way. It's called this, created this new folder, has these things here. And so now we have this existing MJCF to MPy file, which it's not from Kscale. I wrote this. And all it does is loads the MJCF that Kscale just created and renders it in a gym environment. So we can run these, and it runs, and it's this thing here, right? So pretty kind of lame, but okay. So you can see the part, and then there's that thing rotating. and it obviously matches this, right? So it's the same thing, and physics are enabled, of course. Now I am curious to try this PyBullet thing. So let's try call PyBullet robot. All right. No URDF file found. I see. Let me be more specific. Robot URDF. It didn't work. Let's read these. File error not found. Within Onshape robot URDF, it's right there. Copy relative path. Oh my god. Okay. Let's do call PyBullet and then this whole thing. Will that work? Nope. Let's see if the AI can think of something. Zero slash report, yes. But we can't find, oh yeah. I don't think that's the issue. It definitely exists. No, sorry. Call PyBullet default path. Oh, that worked. Now, why did that work? I'm not sure. It's open source, so we can look at the code here. This is now very laggy. Yeah, we could improve this by turning off the UX, but CPUs are maxed out right now. Okay, I guess I can tell it's the same part over there. Similar to our MuJoCo thing, right? So, except PyBullet had this nice thing where like you can control the angle of the stuff, of the mates, and on the sorry, PyBullet had that nice thing, and here I don't see the option for you to do that. Let me ask the AI though. Is it possible to control the angles of mates in the imported MJCF? I know this is possible in PyBullet, but don't see it in MuJoCo. I'm sure there's something for this. Yes, it's possible. Okay. But can I change the position using a UI slider? Because PyBullet had a UI slider, I can just change the position. You can control it in other things. Huh. Well, let's try this. I don't think I have this thing installed. Yeah. While that happens, let's take a look at here. Let's see what's going on here in our evals. PPO obviously solving faster. I think if I remember correctly, mean reward 300 was the max, and we want a high reward and a small episode length, which means we're reaching the end of the course faster. And PPO actually doing pretty well here, at less than 1 million time steps, which is it's nice. All right, this is still installing. And I guess the main takeaway here is that we need to, I guess the next step would be to try to import the entire robot dock onto MuJoCo and see what's broken and what needs to be fixed. Obviously, there's a few things that need to be fixed. Like I'm missing a few things. The legs are not all up to date on latest. And I'm sure some of the mates are incorrect. All right, so that's done. Okay, very annoying. All right, maybe not use that. Should I be using PyBullet? PyBullet SB3. I guess, yeah, what's the plan? The plan is to use SB3 to try to train something here. Let's not ChatGPT. I am going to train a RL agent using SB3 so that a quadruped robot can walk. Should I use PyBullet or MuJoCo for my robot? MuJoCo, here's why. Speed. PyBullet makes it easier to view the models in a nice interface and move joints and stuff. By default, MuJoCo doesn't have this interface. This is probably like a skill issue from my side. Fair point. Okay, anyways. Anyway, so that kind of works, right? You would agree that kind of works. So the next step, of course, would be to just call run the entire thing. Okay, and then MJCF to M. Oh. Okay, so it's possible that something went wrong. Oh, I see. Validation error for assembly, didn't pass Pydantic. And last time this happened, I was talking with the K-Scale team over Discord. It had to do with the way mates were defined. So let's try something different. Let's go downstream here. For example, let's do one of the legs, right? Let's do only one of the legs. I want to suppress this. Press. Okay, so we're to do one of the legs here and delete these. So I want to do call run, just one leg. Okay, still leads to an error. Yeah, it didn't. Check the assembly is still connected. All right, right. So seems like an issue with the way mates are defined here, but this is basically the lowest we can go in our kind of like structure tree, right? So this is an assembly made out of parts. There's no assembly within this. There's no sub-assemblies within this assembly. So if we fix this, we should be able to import it. So let's fix the mates here. So yeah. First of all, I think this is fixed. Unfix all, right? So unfix it. Seems to work. It seems to work. Oh, okay. Obviously things are broken. I think, okay, it doesn't like fasten mates. Is that true? Let's open Discord. There was some catch here, which wasn't in the docs, but some. All right. I suspect it's because I don't really use mate connectors in my own CAD models. Okay. Okay, I suspect replace the mate connectors, fix this error. Okay. So Revolut mates need to have mins and max set. I don't know what I meant by mate connectors. Oh, mate connector, this thing. Okay, I see. So fasteners should be fine. But we don't need fasteners for this. Yeah. All right, so should we just do all of the mates from scratch? All right, so all right, so we have the basic box here. I wish this was on the origin. How do I move this to the origin? Add mate connectors to instance origin. Yeah, you'd think that add mate connector to instance origin. Move. I guess not. I like when things are perfectly aligned with the origin. So we pick this, we pick that. Okay. Top. This should be the top. Yeah, this is not gonna be the top mate. So okay. So this rear right shoulder should be pointing this way. So we're upside down. Rear right shoulder should point this way. And that's the bottom. Yeah, kinda. I can make that work. All right. So faster mate there. So in theory, these should be able to import, right? There should be no issues so far. So we can do call, run, and import these. And obviously it's gonna be a mess, but in theory, particles under the circle. Suppress. All right. In theory, I imagine it's gonna ignore suppress stuff, and in theory, it should run. And so it doesn't ignore suppress stuff. That's interesting. What is this? Suppressed. Okay, can't have anything suppressed, but anyways, did I have? Just find it weird because here, oh, I guess it was our Revolut. Okay, so it should be fine, right? Fastener, made connector, should be fine, right? I think so. Right, so if I go now here, yeah, I spent so much time doing fastener joints last time. I guess, okay, actually, if I do here, if I do a cylindrical here and cylindrical here and move it around, oh, this is the wrong one. Yeah, let's try it. This is a different type of way of doing mates from what I'm used to, but we can try to learn. We're trying to learn. That went terrible. That was bad. Okay, let's try again. Try not to be biased here, because people have told me this part is a pain in the ass. But I'm trying not to be biased, because like really it's just a few mates. Like how bad could it be, you know? Okay, and this isn't fully constrained. They should be able to rotate, I think. Yeah. And so we need to find another cylindrical. Okay. All right. And this, and we still need to define it axially, so they should be able to slide. Yeah. So it's not fully defined yet, so we need one more planar. And so here and here, right? And now it's fully defined. Can't go anywhere. Right, so now that's in there. Now, I want to try. I want to de-risk this by making sure this approach is correct, right? So, what I'm gonna do for now is I'm gonna delete everything and try to import these. Call run. There should be no issues there. I don't see. Oh my god. Delete these. Yeah. Okay, note that OnShape API returns a mass of 0 for standard parts. Okay, right, so that's another thing, right? So we need to define the mass for all our parts. Because the URDF file actually also includes mass. So let's name these CLS636 servo. And I guess we can assign material. It's not about assigning material. Oh, it is about assigning. Like, this is a very bad way of doing this, but let's just do this way, just so we can move fast. PLA, okay. Yes. All right, let's try that again. Obviously, that servo is not made out of steel, right? Got an error. Right, so it looks like we're using some sort of mate that this thing doesn't support. We only have, I mean, this should be fine. Revolute, it obviously supports planar. Fasten, does it support fasten? Yes. Cylindrical, obviously, right? Cylindrical, yeah. So what's the issue? All right, let's try it one more time. Huh. I think what's happening here is that it's trying to make these cylindrical mates joints, and these are not joints. Okay. So that's the error we're getting, not implemented. So fasten, revolute is good, slider is good, planar is not good, cylindrical is not good, pin slot is not good, ball is not good. I see. Right, so that's yeah, that's interesting. I mean, that really limits what we can do here. So let's actually go here, look at their example. Let's see what they were doing, right? Because you do kind of need the other joints. Well, it's not a joint, it's a mate, but yeah, I guess for this guy, yeah, for example, I guess this is all one part. Fastened. So it's all fastened. Okay. So we can either use fasten, revolute, or slider. Those are our options. I'll be back. again. So back to Onshape. First of all, let's bring back all the parts that I deleted. Control C, but it's not working. Dope. We can do a revision thing here. I guess it's safe to revision for every time. I don't know what I guess this is it. Okay, the next one. All right, this one's good enough. All right, now we can restore this to main. I guess that's how it works. I actually never done this before. Cool, looks good. All right, and so cylindrical. Okay, let's remember we can only do revolute, fastened, and slider. Everything else is not good. And revolute, fastened, and slider. Of course, this doesn't say anywhere. You just kind of gotta read the code, but fastened. I don't think I've ever used slider. Okay, revolute, fasten, slider. Cylindrical? No bueno. Okay. I think fasten will work. Fasten is one of those. It's an Onshape thing. Okay, so boop. Okay. So I think we just achieved the same thing there. It doesn't move. That's good. All right. Same experiment as before. We delete everything. And then we go here and run the same thing. Call run. Yep. And these should work. What's wrong? When I rolled back stuff, it also rolled back the mass I assigned to the servo, right? So, yeah, rookie mistake. I totally forgot. That's annoying. We have a bunch of parts that have no mass. We need to assign mass for. And what's important is like the mass needs to be correct because. That's the mass that we will train for in the sim. We got a new error. Seems like we're missing one of the meshes. That doesn't make sense to me. Why would we miss a mesh here? I wonder if there's an extension to visualize STL. STL viewer. What's wrong with this? Okay. My best guess is that I messed up something. Yes. What did you mess up? I don't know. That's a new error. We the first time we're seeing that error. See, I knew this was gonna take time, even though it's in theory very simple. I don't want that. Version 4, don't give me version 4, just give me the version. Yeah, just give me whatever Bro, don't give me main. Don't give me. See, I feel like this versioning stuff just leads to errors. Anyways, let's try again, because like it's like I legit do not know what's wrong. MuJoCo meshes. I agree. There's no mesh file for that. Right? There's only one mesh, and it's both of them. But why? I don't know. I am very confused. The server updated to v5. Is that good? I don't know. There is no mesh file for that. Ooh, should there be a mesh file for that? Why did we... okay, idea. Let's check how it was handling this. Our simpler robot. Meshes for all the parts, base and propeller. Okay, that makes sense, right? Although these are assemblies, what if I was to just do these? Let me try something here. So I'm going to tell robot 2, and I want to insert parts. Okay, parts. Basically, in this robot 1, I had assemblies, sub-assemblies with the part, and then I made it those assemblies. But here, I'm not gonna have that. By the way, which part you click first when mating actually matters. Something that I've learned. But anyways, let's see if this works. Let's see how it handles this. The issue here is that I didn't define join limits here, so there's gotta be limits. 90 degrees, which is kind of annoying. Again, like it doesn't say anywhere in the docs. Maybe I should ask to see if I could touch the docs, but let's see. Yep. Meshes parts individually. So that's interesting. So it works here. Why doesn't it work here? Anyways, let's delete these. I wonder if the naming convention is somehow messing things up. I don't know. And then bring back all the other parts. Okay, restore. Yeah, I don't see an issue. Did you see this thing? I don't want that logo. It's saying that I don't have the latest version. That's annoying. Bro, please don't do that. Upgrade release, no. Properties. Update link document. Update all. Cool. I mean, I don't know. Okay. Call run. Boom. Okay. Assembly is not fully connected. Anyways, let me duplicate these. Yeah, you can do that. Yes. Temp like. I just need to figure out what configuration actually works. And we're lagging bad. We're lagging. Our CPUs, man. We need more. We need more compute. I would like to see the episode length for PPO start to go down here. Okay, delete all of this stuff. Perfect, simple. Execute these. Of course, it will fail. We don't understand why. Call run this URL. Please don't fail. Okay, so far so good. And then for some reason, it's not gonna split the meshes. I agree the file doesn't exist. Just tell me why it doesn't exist. You're supposed to create shape. I agree that the mesh file doesn't exist, but I am not sure why Cole didn't create it in the first place. Here is the official repo. Let's see if AI can do it. Let's see if we have AGI here. Because I'm running out of ideas. The normal process appears to be working. You can, yes. However, there are some warnings. Warnings first, directory structure. I swear, yes, it's fine, it's fine. All parts were automated. Check that there aren't any empty parts instances. Nah. Is properly configured. Oh. Wait, do we have to do something there? What are the options? I mean, oh, okay, you know what? I can just get rid of these if it's an issue. But that's not the issue, is it? If that was the issue, I'm gonna be a little, no, yeah, that was an issue. Verify that faster one made is properly configured. You could try running call with debug logging. Oh yeah, is that a thing? The mesh processing pipeline where call is following to properly save the download is still, yes. Nope. Oh, wait. Is it? Can it not handle imports, perhaps? Uh-huh. Oh, well, it's a part studio. It seems to have no issue creating a mesh for the servo. So it's not a permissions issue. Let me see these. Let's see if we can actually run call log level equals debug call. No. Let's see if that's an actual thing. It failed. Cache. Okay, I ran it with call log level equals debug. Now what? No. Could you share the debug output? Where can I find the debug output? I guess it's cache here somewhere. No. JSON. Debug output. Cat. What? What are you talking about, man? Dude, I don't know if it's hallucinating or what, but what is he talking about? Alright, so what if it's not these? Going back to these. Okay, so call run, yeah, for the 10th time. Obviously, this leads to an error. obviously we can see that the error is because it's not splitting the mesh as we would expect. And why would it not split the mesh? Why would it split the mesh wrong? Right? RSH rear 1. Yeah, why would it do that? Looks like call is failing to split the mesh properly. Wait. Instance part instance not found in key to part instance mapping. Fasten1 has entities. Fasten1. We don't have Fasten1 anymore. There is no Fasten1, dude. To use the latest functionality, we'd like to update to the latest feature library, I guess. That is right now, so it's updating right now. So was this an ownership issue all along? It could be. I'm not even mad. I'm just used to ownership not working. Okay, returning a massive 0. Classic. No one is returning mass 0. Nothing is a standard part. But of course, okay, patience, patience. Alright, back to the normal error. So let's see the mesh here. Obviously fails to split the mesh again. Interesting. Why would it fail to split the mesh? How does the mesh splitting logic work? So mesh. I guess I can ask the AI. How does figure out where to split different parts to create individual meshes? Okay, create a mapping part. There's nothing with an empty name though. So maybe one of my names is throwing it off. Like, okay, one of my theories here was that it didn't like commas, rear right servo box, right? That was like one of the theories. So if we get rid of commas, maybe. The mesh for the servo still doesn't exist because the mesh of that part is in same STL as another part in the assembly. Not like that's gonna make sense to the AI. Just notice how only the first one gets a part. I understand. This is a common issue when working on assemblies in on-chip. No, it's not. The best practice is to separate the servo into its own part studio. But that's what I'm doing. If modifying the on-chip okay, idea. And I'm not saying this is a good idea. I'm just saying idea. Assembly. Okay, what about that? Like if this works, I do not understand why it works, but it works. It didn't work. Why didn't it work? Same reason. Meshes are still together. Why? Don't get it. All right, now I have to delete these. Duplicate these again. Like temp and delete all of this stuff here. Okay. I guess we don't need that. Just we'll just fix this. Okay. Is it an issue that the parts are colliding? Is that the issue here? Could be, right? Solution, modify the part. Issue, solution, easy. All right, let's see. Oh, this entire thing is crooked. It doesn't matter, it's just funny. Remove maybe like 10 millimeters, maybe like 5 millimeters. The sketch is compromised, I think. Why is it being weird? Okay. All right. I mean, honestly, if that was it, it would be kind of frustrating, but I would feel like kind of like a genius. Call run. I mean, it will kind of make sense. It didn't fix it. I'm hearing quiet because actually, it's while I'm trying to, yeah, it just gives, getting quiet because like I'm running out of ideas. Maybe it's lunchtime. Let's see how TensorBoard's doing. Reward functions are we're still early, but yeah, I'm running out of ideas here. Call mesh. How does create meshes for parts in assembly on chip? Let's see if the AI can help us understand how that code works. Looking at a precision structure. Okay, I see the Onshape API. Convert the vrep boundary representation geometry into a I am running into an error where multiple parts in an assembly are meshed together, and I'm trying to find why that could be. I guess that's like, does it recognize there's multiple parts, right? So mesh found name, of course it does, right? Yeah. Else it wouldn't be looking for different meshes. So every part has visual and collision. Visual collision. Why is there two servos? Is it because of the mates? Servo, why is link right rear servo box 1? Okay. Well, let's ask how many parts are in this assembly. 2. There's an issue in this file that is actually defined twice with different joint connections. You can't have two links with the same name in a URDF file. But they don't have the same name. Wait, so okay, so if I remove one of the links, will that solve this issue? Let's check. I mean, again, if this works. Oh, no warning this time. Oh, this worked. Wait a second. Okay, they're meshed together, but correctly. Huh. Well, but is this fully constrained? It is. Okay, so I was messing up by over constrained with double fasteners. Which is kind of annoying. I'm gonna put some food up in the air fryer. Human error. I was blaming the computer. Computer never wrong. Human always wrong. But human. I actually need my phone to measure food. I'll be back. But human will be back. Alright, I have some food in the way. You can hear in the background. Now that I know how this thing works, let's get to it. Let's finish the entire robot. Alright. No longer need this temp file. Can start working here. We learned we only need one fastener per actuator, one fastener mate. So let's do that here. Fastener mate, fastener. And just like that, we fully define these, right? That's still kind of interesting to me. The mates that are allowed are fasten, revolute, fasten, and slider. Nothing else. So for example, for this one, I think that will be obviously it's a servo horn. It's a revolute, right from there to here. That defines it axially as well. Yeah, perfect. Except not perfect, because I placed this on the. Oh no, this is correct. Okay, yes, perfect. Okay. So now this one. And by the way, I already know there's an issue here. The issue is that I didn't put a maximum and minimum revolution thing. I'll come back to that later. I don't know how to tackle that right now. Because our servos do 90 degrees, but it like kind of depends. This is a fastened mate from here to here. Maybe not like that. See, now this doesn't line up. How do I? It is a fastened mate for sure. Okay, maybe I can use the middle one. It doesn't line up. Yeah, what happens when things don't line up? Actual serious question. What do I do now? Are there more tools for this? What is this axis based on? What is these axes based on? Do I just? I mean, closer. No, right? No. No chance. So these axes, it's like... yeah, it's like they're off. They're off by... Why are they off? Why are they off? Can I move it? Move it around? No, so it's not off. If I go there, is it still off? No, it's better. Still off, but it's better. That looks basically perfect to me. I think this is just me being a noob in on shape. So I'm probably doing something obviously wrong. I just don't know what's obviously wrong. It's like, oh man. Okay, so these axes didn't rotate. So it's a fixed axis. What else can I guess I have some more control over faces to connect. So this face, oh, I can't access any of the other faces. Rotate around X 45 degrees. Wrong axis. Rotate about Y. Rotate about Z. That does it. Okay, interesting. So that's how you handle that. Huh. Okay. That'll do it. Okay. So that took forever. So we have slider, revolute, and fast surge. Revolute here, revolute here, right? That one's easy. Okay. Here. Right. Oh. I guess there's an offset here that we're not capturing. Offset, axial, 5. No. 0.5. Minus 0.5. Minus 0.5. Minus 0.2. Minus 0.1. And I shouldn't be guessing, I should just measure, but okay. That's perfect. Okay. What's annoying is that I think we have to do these for all the other legs as well. Oh, I did it. No, I did it right. I thought I did it wrong. I was gonna say I did it wrong, but no. Yeah, I think we need to do this for all the other legs as well. And there's 4 legs, right? So this is gonna take a while. I'm gonna hear her all day. Just do it. Alright. But hopefully at the end of this is okay. One more part. This was kind of tricky because it's a revolute. Oh, I guess you got rid of the retaining ring. Revolute. When did that happen? I totally forgot about that. How does this actually work? Revolute here. That sits here, right? Something like that. I think so. We'll do a cross-section view to specs. Yeah. And 2 more revolutes. And now remember, for every revolute or revolute or whatever you call them, we actually have to define minimum and maximum angles. I think that's what. Oh, something broke. I think that's what K-Scale is expecting. This is breaking stuff. I don't know why. I think it's because there's an offset. Yeah, there's a 0.1 offset. What about here? There's a 0.4 offset. This one's an easy fix. 0. So now these should work. Right, that works. But now we have another offset to take care of here. My food smells really good. Why are those moving together? .4. Move face. 0.4. And of course things should already line up. I just, I was cutting corners at some point, and that's why things don't line up. Alright, now everything should be perfect. Okay, so in theory, these are all the mates, right? So this is our legworks. Yes, right? Now, it's not that easy because if we were to try to import these to MuJoCo, it's gonna give us errors. It's gonna say that we haven't defined min and max for the Revolute mates, right? The assembly has parallel connections. Okay, I don't know about that. What do you mean by parallel connection? That's a new one, I guess. Do we have parallel connection? No, Revolute fastened. Okay, this error is coming from trying to export an on-shape model to URF. The key issue here is parallel connections cycles in its joint structure. Upper leg upper into right lower leg simple. Upper leg, so here into these here. Lower leg simple. Okay. 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 Now, oh, actually, where is it? Here, right? Now, if we were to define limits, and one of the limits was 0 and the other one 90, would you still complain? I think not. I think you would not complain, right? But let's try it. And the air fryer is calling me, but this can wait a little bit. Upper leg upper into lower leg simple, still no problem. Huh. I am not sure what it means then. This is likely because you have a 4-bar linkage or similar mechanical linkage in your robot design. To fix this, you need to go back to Onshape, break one of the connections. Wait, so URDF support 4var? That is hilarious. Wait, so does URDF not support 4var linkages? Wow. So URDF doesn't support 4bar linkages, and our robot basically each leg has 2 4bar linkages. Does MuJoCo support 4bar linkages? I'll be right back. I'm gonna eat a little bit. I'll come back. We need to fix this. Let's take a quick look before that at our tensor board here. Episode length holding steady for PPO. Still early for the other ones. Yeah, pretty early still. PPO already at 3.5 million, and CPUs are fine. All right, we'll be back. All right, I'm back. Yeah, so it looks like URDF doesn't support 4bar linkages, and I actually was talking about this with ChatGPT. URDF does not natively support closed kinetic loops, and there's some workaround ideas. But really, we don't care about URDF as much as we care about MuJoCo files. We only need the URDF file because I think that the way the Onshape pipeline by K-scale works is Onshape to URDF to MuJoCo. And so we can have a broken URDF file and then on the MuJoCo thing manually fix it. And so for MuJoCo, it says MuJoCo can handle 4bar linkages natively. So it supports closed kinetic chains by introducing constraints that enforce that requirement motion. You need to use something that's called a equality constraint. Okay. So the real question here is whether we can get far enough along with when URDF. And later on, we'll deal with MuJoCo manually, right? So let's try again. Let's try doing this again. Call run this, right? Would this work? Oh, I guess there's actually multiple 4-bar linkages here. Yeah, so as long as these, let me try again. As long as these can be translated to URDF, we can probably manually, yeah. Okay, part should have a positive mass, so I'm missing mass. I guess the other thing to note was there's other open source quadrupeds like the Dingo quadruped, which has a URDF. So we have a question of how are they doing it? There's a Stanford Popper, I think, that also has a URDF. So it'll be interesting to see how is it that they're doing it. So putting that to the side. But yes, we need to make sure none of these parts have that all of these parts have an assigned mass. So that's pretty straightforward, actually. I think for material we're using PLA. There's a PLA. PLA material 3D printed on shape material. Oh, TensorBoard, SAC rewards are starting to jump up. That's good. We can close these now, and PLA density, nice. PLA. I don't know, when you search PLA, a lot of other things come up. Not PLA itself. Anyways, we are learning. That's what matters here. Next time we do this, we can be faster. I do wonder what else I'm missing, you know, it's like, I kind of never know when doing something for the first time. All right, was that all the parts? We can try again. And yeah, in theory at least, modifying a URDF file manually should not be a huge deal. Okay. So now it's like the join limits are not defined, right? Which is something that I was talking about earlier, right? So this is only true for Revolut joins, right? So for example, this one here, right? So it kind of depends where 0 is, right? So 0, like let's say 0 to 180, right? For example. And like and I think it doesn't like negative angles. 90. Right, so if 0 is there, we actually want to go like -80 or something like that. But it's not doing it. I guess the other thing we can do is just define fake angles, just to get it done with. Right, like how do you find the limits? I mean, I guess 0 to 360. We're just trying to get something out the door here. Limits 0 to 360. Right. Which I guess it's basically saying no limit, although the limit is 1 full revolution. You can't do more than 1 full revolution. And then last one here. And that should be enough to meet our condition. Call run here. Let's clean this up. And then run this. No errors. I'm very tired. Hey Siri, turn on the Christmas tree. Okay. There's some warnings. GM with duplicate name blank. But other than that, it looks like it has resolved. And so now we can go here and then we can open the MJCF file. I see. You created the file with a different name, which makes sense. Okay. So this should be our leg, right? Like you can see, it is indeed the leg. Physics looks, I guess, the joints are moving as you expect. But of course, the linkage is broken, right? Which we fully expected as well. And so now we could do two things. One could be to do the mates for the rest of the robot and just trust that eventually we will figure out how to make this work. And second, the second would be to make this work first. To make this work first, basically. What do you think? What's more fun? We can try to make this work first. Why don't we take a look at, let's see what URDFs the Dingo has, right? So Dingo, this has crashed. Pushing the CPUs, I don't know what's going on here. I'm gonna close some stuff here. I'm gonna close Discord, gonna close messages. All right, so I'm gonna close this stuff here. What's going on here? Well, PPO is really doing decent here. Should we take a look at what this is looking like? Oh, the reward's dropping. Yeah, so we could look at Dingo. Dingo quadruped looks like this. It's actually very similar to my quadruped, right? Like same 4-bar mechanisms. The body's completely different, but the legs are basically the same. If you don't look at the lowers, and you know they have push rods and stuff, but it's basically kinematically it's basically the same thing. And so these guys have a URDF here, right? And so 4-bar. And so what we could do, especially if they have the meshes here, which they do. And all right, so there's no MJCF, but we could potentially open this, I think. K-scale pi bullet on shape using the K-scale library. We could do pi bullet. Yeah, we can 100% do that. So if we go here, can I just download? Main. I guess you have to download the entire thing. You could do git clone and all that stuff, but I kind of don't want to. So Antarctic, aerial learning, bipedal, no, MuJoCo. on shape, temp, put it here. All right. Learn, MuJoCo, on shape, temp. Open these. Gonna open another one. Man, I am really tired. Falling asleep. On shape. Okay, so here. Let's go look for it. Assets. Source, description, mesh, and URDF. I think so. I think that's basically it. All right. So K-scale requires, if we look at here, the onshape library. Let's go to docs.kscale. And there's the utilities onshape to URDF, PyBullet call URDF path, right? So we can go here, we can do temp and then do call PyBullet URDF dingo.urdf, I think. Error. Just an error in how, because of how because of where the meshes are instead of let's remember. Oh no, how did we? Oh yeah, okay, all right, this should work. I think. Let's try again. Actually, less. Yeah, so PyBullet dingo. These might be a little heavy, by the way, on the computer. Maybe we might get a little lag. Oh my god, I thought that was correct. Temp. Dingo URDF, meshes, yes. Can I dingo description? Oh. That's interesting. Call PyBullet robot URDF. I always forget what's the file structure that this thing is expecting. Robots. Yeah, okay. See, I just opened the lag here in PyBullet. It's really hard to see. I mean, it's gonna be laggy here, but let me show you, right? That's the lag. That's what we just did on onshape. By the way, interesting to see that the colors translated, and you can hear move the revolutes, which is cool. Okay. So what worked here was robot URDF, and so let's just copy the same thing. New folder. I'm gonna put robot move. I'm gonna name these robot, and then the same thing. And these might not work just because of what's inside the URDF itself. Yeah. Okay. So if we look at this URDF, Dingo. Okay, I see. File node package meshes. Okay, so it's expecting a different package Dingo description, and then we put that here, and I think that should work. Dingo description, yeah. You gotta put these things in here as well. Make sure. It can work. Make sure you're running the command from the correct directory where robot URDF. Okay, I see. So we're gonna go to robot, cd robot, and then okay. So that appears to be working, right? So what we're looking for here are working working 4 bars. And you can see here that the 4 bar elements are actually missing, right? The push rods are not there. And so that's how these guys, the Dingo guys, worked around MuJoCo, or sorry, URDF not handling 4 bars. So I guess that's one way of doing it, and then yeah, I guess that's one way of doing it. Yeah, that's interesting. Yeah, so we could do that, and then basically you just do some math to translate from the servo movements to the required leg movement. So that makes sense, and I guess it's computational, less intensive. I'm gonna delete this Dingo stuff now. I was wondering if they had a more clever solution, you know? I don't want to be a hater, you know? I just thought these guys were maybe a little more sophisticated than that. Not hating. Okay, so we could do that, right? And we can ignore it, remove some parts here, or we could figure out in MuJoCo. Actually, hold on. First, let me regenerate this. In a MuJoCo MJCF file, how do you express a 4-bar linkage? So that seems pretty normal. Wasn't there a need to have an equality constraint? I heard something like that, equality constraint. You have to correct the 4-bar linkages in Oracle. While it figures that out, I'm gonna get it. let's see it. And first constraint, okay, equality. Where is it? Equality here. Well, Barb. It just doesn't give me a lot of confidence. But okay, we move on. Okay, so things are gonna look wrecked for the time being. I mean, that's not gonna look great, right? The entire body. Oh, let's see. We had a temporary leg here. Yeah. Okay. Not a big deal. All right. Yeah. So all our mates on Onshape are gonna look wrecked. I mean, what's the cleanest way of doing this, really? If there's a clean way. There isn't, huh? I guess I'm gonna fully constrain everything, and then we'll have a different assembly file for just for MuJoCo purposes, and then we'll fix all the required stuff there. I don't know. Does that sound like a good idea? Any reason why that would sound like a bad idea? No, right? Hi. All right. Okay, let's keep going. So this guy is not looking, doesn't move for some reason, and I think it's just because of the limit on the revolute mate I set here. Here, no. Here. Right, so I'm gonna get rid of this limit, and then I think it will rotate freely now. Not quite, kinda, not quite. Actually, all the limits here are very annoying, so I'm just gonna remove limits for now. And then eventually, I guess we'll figure out the correct limits to have. We'll have to calculate some stuff. Mates are breaking, I don't even know why. All I did was remove some limits. Let's see this here one. All right. So let's see where we end up with that. Nothing, this guy, okay. So now this guy moves. I mean, it's a little laggy, but I think that's just on shape. Yeah, you saw me drag that, it didn't move. Okay, now it moves. Revolute. That looks completely wrong, but okay. How is that even possible? How is that? It doesn't matter. I'll fix it. Okay, so revolute, go here, and okay. And that's basically it for the first leg. It took 1,000,000 clicks and it's still broken. And so now we repeat the exercise for all the other legs. and the whole body. So around 5 more million clicks and we'll be on the right spot. But I guess first, the first thing we can do here is put back this leg in here. And we can try to do it in the right way. So there should be a rear right leg. Oh, it's called copy. I want to clean the name. Shouldn't be a copy. Okay. Insert it back. All right. Let's see if we can rotate it without breaking everything. Pretty sure you saw me click rotation, right? And then it just drags it. Okay, and that's clearly a Revolut mate. Here. Oh, did I? Oh no, yeah, it's correct. Okay, I guess I can keep doing legs. I can do the front right leg now. And well, first of all, yeah, get rid of all of these joints. It's all of these mates. And then we need to fix the upper. So stuff that I've been putting off for a long time. So insert. It could be these, but I'm not sure. One of these for sure. Not that. Just bring them all, actually. Yeah. What's the difference? It's not these. And but other than that, they look the same. Let's check the names. They all name the same thing too. It's not these. It's not these or these. It's one of these two. But they look the same. And it's not these either. Or these. We don't need that. I guess this file just has duplicate parts for no reason. Okay. So either of these will do. Okay, this is also an old part, pretty sure. The retaining ring is not used anymore. And so this part got updated. So this shouldn't exist. Okay. And we can fix this for now. Oh, it's already fixed. And then this is a single fastener joint. And then same for this one. This part also changed, so you need to go fish the updated part. Oh, and that's it. don't know if that's perfectly centered. Doesn't look like it. 0.4. 0.1. So this should be 0.25. But I think on these other, like, it was perfectly centered at 0.1. Let's check. Which means the geometry would be, it's different. Yeah, it looks perfectly centered. Yeah, so that must mean that, let's see. So we thought all of these lowers were the same. They probably are not. It's just the differences are very small. So if we look here, there were probably changes made here. This is probably different. Actually, not this. Not here. Not here either. Well, let's measure. Hard to measure. Impossible to measure. Let's move the tree, I guess. Okay, well, maybe it's not this part. Maybe it's the upper. Maybe the upper changed. But I'm pretty sure we said we wouldn't change the upper. Can I copy and paste it here? Turns out I can. But rotating doesn't work. Yeah, no. Okay, let's try that again. Nope, it's still not the same. But this is wrong also. Should be negative. I guess that's a pretty big change actually, 0.2. Yeah, looks about right, looks right. Looks good enough. I'm not even gonna check. We're lagging. All right, and then last one. The hardest one, but last one. And then there's an offset here, 45 degrees. On the other axis. Yeah. Good enough. And they should be able to solve. It's saying it's broken, but you should be able to solve. Yeah. How is this broken? Not here. Is it here? Could be these. Let's see. Yeah. Yeah, so there must be an offset here. There's like interference, which is interesting because we just changed this part. 0.5. We just changed this part for it to line up on the other assembly. So I can change it, but it's gonna, right? We have these here. If I change it here, it breaks the other one, but they should be the same. So something else is off. Let's take a look. Maybe in here somewhere. So that looks good. Let's check here. Also looks good. Right. Looks the same. Yeah, looks the exact same. So not there. These parts should be the same. And then this part obviously is the same. So is this part the same? Let's measure. 8.1. That's the same. And then a quick check here, from here to here, top to top, 9. .5. So that's the change. What about here, top to top? 12. Okay. So the difference is in the knee somewhere, or it must be in the knee somewhere. First of all, that's interference right there. Let's try to find here. Okay, this guy here. Wrong face. Yes, wrong face. That must be it. And that's the thing with having chamfers on these faces. Just makes the mates harder. All right. So that's another one done. Halfway there. I guess the one thing we're not checking is like making sure the masses are correct, but that can happen later. Okay. So this is wrong. All right, and remove that. Don't need it. All right. Then insert a new lower. Just try to remember where this part lives. Somewhere here. Yeah. Which one do we want? Probably. Okay, not that. Oh, I see what's going on here. Let me start again. The lag is really bad. I think just being browser based, like it's a disaster. All right, it's this one, pretty sure. There might be a desktop client. Yeah, and it won't rotate. Classic. All right, and now we can delete all the mates. Of course, it lags too much. It's kind of back. It's kind of back, yeah. Oh, and I guess there's probably a retaining ring somewhere in here. Yeah, remove these. Update these. So slow. Okay, let's see if it updates correctly. Because we need the mirrored version of it. Looks right to me. We did some parts did go missing here, and I'm assuming that's just lag. Yeah. As soon as I refresh, they come back. Let's take a look at TensorBoard. SEC reward function, the min reward is climbing. Almost at PPO levels, not really. But the episode length are much higher than PPO. Not necessarily a good thing, of course, right? Actually, faster, lower episode length with a high reward is what we want. All right. So let's see what we have here. This is fixed. That's good. All right. Dude. Okay, I think that's done. Now we do servo horns. Actually, I didn't check if these legs top assembly mates survived. They did. Okay, interesting. We need to like also clean those up after, so it doesn't matter too much. This is a rear left. Rear left goes somewhere like here. Yeah. The hip is up, I think. Hip. Yes. All right. This needs to be updated. Actually, there's no there's a retaining ring groove here. This is an old part. So this is closer to what we actually want. This is the mirrored version. Oh, but it's incorrect. So that's what we actually want, part 3. I'm gonna steal this name. I'm gonna add archive here. And I put it here. Okay. And so these should say archive now. It doesn't. But it's also an old part. So we can update it. We can't really update it for some reason. Update all. That is still incorrect. So it's not even pulling the right name. It claims to be this part, but it's not. Is it? It's not. It's this part. That's not what I want. Anyways, I'll just delete it. I guess insert the new one first. Oh, the names didn't. Interesting. The names didn't update. All right. That's just onShape being useless. All right. All right. We can do, I guess we can do this one next. this part looks actually out of date. Because the new ones have fillets on the inside. So let's double check here. Yeah, I don't remember. Right. So I guess, yeah, I guess this is incorrect. But this is also incorrect, right? Because like, look, this guy has fillets on the inside. But I think the upper is the same for left and right. So I can just go here, go here. Can delete these, place the new one. This is not enough on its own. The lower is also incorrect. Okay. All right, and now, so this guy here, it's out of date for some reason. You gotta figure out where this guy lives. Actually, let's just measure. The easiest way to check this gap here. 5.9. It's probably more than 5.9 here. 5.9 should be perfect. Oh, and go back and don't hide the upper. Yep. All right. All right, so now 0.1 should be plenty. Minus 0.1. And let's triple check. And that's perfect. All right, and then last thing here is this linkage element. Oh. Not as cylindrical or revolute. And it's broken because of an offset, which I think I understand why. Right, it's probably like 0.4 offset. Yep, there you go, 0.4. I think this is too high, 0.4 too high. This linkage really gets complicated, really just likes breaking itself. I mean, I doubt this is gonna help, but maybe with one more constraint. Said no one. Yeah, no. Let me check if I did this right. Oh, I don't think it has updated. Yeah, it doesn't look updated. Also, why is it called part 3? There's nothing called part 3 here. That's odd. Definitely not that. Yeah, that should be perfect. So it's this assembly that has not updated that's breaking things. And there's no such thing as part 3. I don't know. Refresh. Nope. All right, change names maybe. Move face. Yep, move face. Rename to new. But it doesn't want to update, which is odd. I mean, we could delete it, but it seems unnecessary. It's definitely not called part 3. All right, fine. We can, I guess, okay, we can insert a new one and then delete the old one. It's interesting that it says part 3 here. So it's aware. What does that even mean? I don't know if that's, I mean, the names make no sense. It's just ignoring what the actual part says. So this could be anything. And that's not it. So, what does this mean? Update selected. Update to latest. Doesn't want to. All right, great. Update all. Great. Should I just delete the archive? Yes. Alright, just delete that. Start from scratch. Should not be, yeah, even these. How can it be showing me parts that don't exist anymore? What about here? Nope. That's not it. That's also not it. That's interesting. What if I manually go and open it? it's these right here. Right, so only two. None of them are whatever that other one shows. I'm gonna assign material PL8. Oh, it's already PL8. Yep. Close these. Try again. That's impossible. I don't get it. Don't understand. All right, let's try. Still wrong. I guess we could copy and paste it in. Shouldn't have to do that, but we can. Right? Oh, it doesn't work. Interesting. What if I open it on another assembly? Like here. Oh, there it's correct. Okay, except I can't see it. But it's technically there. Alright, now I can see it. Alright, now I can copy and paste it here. And of course that makes a lot of sense. And unshaped's not a joke. Alright, here we go again. Okay, and then one more. And that'll finish this leg. And of course we still have one more leg. And of course this is also upside down. Oh my god. All right, let's see it on the top assembly. Yes. Now only one more to go. Let's take a look at tensor board. Okay. Rewards are climbing even for TD3. PPO is almost at 10 million time steps. Episode length is basically dropping linearly. So that's good. All right. I mean, it's okay, right? It's not very efficient, but it's okay. Anyways, all right, so we need to delete these, this, and then this, and then we go here, and we can copy this, this, and that's it actually. Everything else is the same. It's the same. Yes. Oh, and then delete all the mates, of course. It's the most satisfying part. All right. Revolute. Here. Here. All right. I guess we can do one more here. I already clicked, okay. I click, nothing happens. Click again, sometimes something happens. Fastener here. Yeah, we can do fastener here. I mean, the easiest thing would have been to rotate these and connect it. And then offset these 45, and then rotate once, and that's kind of it. And everything else is just revolutes with offsets. Pretty straightforward. Okay, I'm clicking 3 times now. Okay, finally happened. Let's see. I think that's basically it. Let's see, top assembly. Top assembly looks good. Of course, there's also all of these mates that we need to clean. And I think the main thing also is all the electronic stuff. That a lot of these doesn't have clean mates. The battery, for example, there's no mate for that. And so we could leave everything where it is, but we really don't need this detail. So we could leave things on this assembly, but then on the MuJoCo assembly, basically replace all of the electronic stuff except the actuators. Actuators might as well stay because they help with the mates. We could replace all of the electronic boards with a single object that's representative of its mass, and that would simplify things. We're almost there. I'll be back. All right. So I guess as a next step, we could just partition our top assembly onto a MuJoCo simplified version. Let me try to figure out where this was. Which uses all of the same parts except, wait, where is this thing? Uses all of the same parts except, wait, actually, where is this thing? That's not it. That's not. Nope. Is it in here? Is this it? Huh. Antarctic. Basically what I want is a copy of these in a separate, or I guess I can just do it in document here. And I'll call it robot. That's one way of doing it. And robot doesn't need these. Right, Arduino Uno can go, busbar can go. What is this? The battery, don't need battery. Robot doesn't need buck converter. Alright, and then robots can do without all of these mates. Let's see what's standing. Okay. All right, and so we're gonna set the torso as fixed and then reconstruct around it. And I think that'll work for the most part. Except of course, we're gonna need a, wait, what is this? Unfixed. We're gonna need, what are we gonna need? We're gonna need we're gonna need revolve mate limits, I guess, which seems easy on the shoulders, kind of hard to figure out on the legs. Or we could just break the 4 bars. But if we break the 4 bars, then we're gonna need different leg assemblies for the MuJoCo stuff. And that's more sub-assemblies to have to maintain, which isn't ideal, right? So plenty of good reasons not to do that. Wait, can you hear this? I think you can hear it. Oh, never mind. I was gonna put music, but I don't want to get copyrighted. All right, let's keep going. So easy easy one made here. All right. We need to move the servos just to expose the mating features. Not a big deal. It's almost done actually. And I'm gonna leave soon because I'm going to Costco tonight. I just want to finish this. For the first time we have a roof, and then all the remaining stuff are revolve mates here. No, not like that. Oh my god. Alright, fine. Revolute mates, revolute. Okay, and that's all the mates basically for the top assembly. And we can attempt a import right now. Obviously it's gonna fail. I know it's gonna fail, but we can attempt. Let's attempt. Right, there's like, I can think of two reasons to fail, right? One is loops, so aka 4 bars, and then the other one is no limits, and then the other one, actually the third, it would be missing materials for some parts. So let's see. Check that the assembly is fully connected. No parallel connections. Yeah, parallel connections. All right, so we are, let's see, assembly has parallel connections. Yeah, all right, we fail on the top bar. All right, it could be useful to see if we can skip the URDF stuff on the K-scale stuff. Let's see. This SCI. Can you walk me through how this works? Does it go from Onshape to URDF to MuJoCo? Can we go straight from Onshape to MuJoCo? Based on the written repository, this appears to be a yes. However, you don't see directly for URDF or MuJoCo commercials in the public. Oh, the rack just sucks. Oh wow, that's bad. not writing a custom script. So in theory, on shape, schema, features. Okay, so yeah, just ignore what the AI just said. Obviously, it's doesn't have full context here. That's why it said something dumb. All right, let's see. All right, so with the K-scale stuff, it goes from URDF to MJCF, right? So the first step is URDF, which is the problem. So I don't think that this library is going to help us unless we break all the 4 bars. We have 8 totals for 4 bars, which is possible. I just think it's kind of lazy. So on shape to MJCF. Is it MJCF? MJCF, yeah. I'll throw MuJoCo in there. On shape to MuJoCo. Yeah, everyone does URDF first. So I guess in theory, I could I could break all the 4 bars. You know. It's just such a... Oh wait, first of all, can I even duplicate these? Can I? Looks like no. Yeah, so the idea would be break the 4 bars just for the URDF, and then manually rebuild the 4 bars on an XML when going to MJCF. And I don't know if that'll work, right? But in theory, why wouldn't it work? Yeah. Why wouldn't it work? I would feel much better if I could just make a copy, because breaking the model just for one export seems dumb. Copy workspace. Create public document. Huh. Can I move these to its own? Okay. So now there's a separate file for MuJoCo. The issue is that all these sub-assemblies are not here. Right, those still live here. Yeah, I mean, that's not great either. And now I can't just open this stuff. Can I? I don't think I can. Oh, can I? Oh, I guess I can. Can I? So I could remove parts? Wait, so if I remove... It's not clear to me. Where does this actually live? It's not clear to me. It's an Antarctic top level, right? And if I was to delete one file here, oh, first of all, I can't delete it. Editing context, not really. Huh. Can I put this back in here? Nope. Move to. Okay, so it looks like you're able to transfer out assemblies, but you can't put them back inside. Alright, you can move to document. Alright, that kind of sucks. What would be cool if I could make this, it's like standalone thing, but I can't. Can these move? Yes. Alright, so they may still work, but these files obviously are not, like these files live somewhere else, right? I imagine. I didn't just take them. All right. Okay, so this is useless now, and now I need to recreate it again here, right? And once that's recreated, I still need to remove the 4 bars. Alright, let's get started. Like, I already know this is gonna take too much time, so I'm gonna call this URDF robot. Alright, URDF robot doesn't need Arduino Uno board, doesn't need buck converter, URDF robot doesn't need battery, doesn't need bus bar. URDF robot doesn't need any of these mains. And URDF robot needs a fixed torso, but nothing else needs to be fixed. And URDF robot needs things split apart so the mating features are exposed. And I know I just did this and I'm doing it again. It's like a nice waste of time. Hopefully we learn something. For example, to never trust on shape. Alright. Okay. A couple more. Not like that. And after these, I'll break the 4 bars once, but only once, and I'll export these, and hopefully I never have to break it again. And I'll just work with the exported file and recreate the 4 bars manually on an XML, which sounds doable. Just haven't done it before. All right, that should be it. Quick check. This should be able to rotate, 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 rotate. Should have a cap, and none of these should move. Perfect. All right, that's the MuJoCo thing. And all right, now just to like quadruple check, but I already know this one work. It's like call run these. Also, let's triple check the K-scale docs here. You're just MuJoCo. Yeah. All right. So I don't think we can do anything about these. At least, unless. Oh, I guess now we can't do that. Well, what does download look like? Let's see. Yeah, I know this failed, but because I wonder if there's like a text representation of a file that we can modify that's gonna be easier. Oh no, can't even download it without getting the parallel connection error. All right, so we're gonna break the file first, then download, right? All right, what's the easiest way to break these? Also, I guess the other thing is you cannot just suppress. You actually need to delete. Yeah. Right. Let's try suppressing. Suppress and then suppress. Right. So now it's not really a 4-bar. There are no 4 bars here, but it's not enough. Because I guess it still downloads the mates. Oh. Oh, okay. We can suppress. Suppressing is fine. Alright, so we'll suppress everything equally. Well, I guess the other thing are the limits, right? We need to figure out the limits. And I guess the limits only go one way. So these limits are actually kind of dumb. What if we don't set limits? Yeah, what if there's no limits? Why does that break? Okay, well, for some reason this breaks. This also breaks it. I don't understand why. I guess it's breaking it because there's some conditions where that wouldn't work. This is just not a good environment to define limits. This is like defining limits for kinematics in real life. It's like really bad. And like this assumes rotation in only one direction. And why is 0 starting there? Uh-oh. Interesting. Oh, okay, this won't be too bad. And I guess I can just use the safety envelope from where? Safety, servo calculations. Safety envelope B2. Rear right hip from 0 to 125. And 0 wasn't 0 here. See, I already forgot how this was assembled. Also, that's hip. We're looking at knee here. So 40. So was 90 here. So 0 is here. So it'll be from 40 all the way to 165. Let's have it play. Okay. That looks right to me. What do you think? Too much, right? Obvious collision there. But kinda. Oh, it's because that wasn't actually 0. So if we calculate this angle here and we divide it by 2, so 18, almost, okay, so if we shift everything by 10 degrees, so here, so if we, actually, I don't know if it's going to be linear, but 155, something like that. So kinda, right? Yeah. Still though too much there, but I think we'll also only need to solve this once, and it'll be the same for all legs. It's funny because this is probably what we should have done before when trying to figure out the maximum travel for our servos. I just think this is a waste of time because MuJoCo will not permit meshes to clash anyways, so like the RL agent's gonna solve for all of this stuff, but whatever. Now this one here, it's whatever, like literally doesn't matter. Like I understand it needs some sort of limit, but it literally does not matter. I wonder if that's gonna break anything. No, it didn't break anything. Okay. That one does matter. Oh, actually, this is another one that does not matter. You can put whatever limits you want, and it's basically a driven joint, right? So it's defined by the 4-bar around itself, so it doesn't really matter. Same with this guy here. It's defined by the linkage around it. This is the knee joint. It doesn't matter. Now, I don't know if 0 and 360 are good. Yeah, it's probably not good. Okay. Thing is, it doesn't like go into negative values either, so. I wonder why. Why does it need a limit? Yeah, why does this need a limit? Check that the joint limits are defined on all relevant joints, replicating joints. Okay. Well, what about now? What about... How do you know what the relevant joints are? Sorry, my bad, I forgot. I mean, it failed because we have 4 bars, not because of the limits. But yeah, the limit thing is kind of lame, so the limit thing might want to make me go somewhere else. Like, the limit thing seems like a safeguard that I don't need. There is one more on-shape to your DF library we can use. I already have that. This might be a tomorrow thing, I think. I think that's enough for today, and then we'll just leave TensorBoard running overnight. PPO is already at almost 12 million timestamps here. Maybe like the compute is better spent on the other models. SAC looks kinda interesting here. Episode length is coming down. Mean reward is at 300. That looks good. All right, let's evaluate some PPOs for now. See where we're at. LS, CC, LS, CD bipedal, LS, bipedal, SV3, LS, CD, SV3, experiment 3, I think, LS, CD, no, sorry, Python, evaluate, bipedal, Py, algo, PPO, what's, what checkpoint do we want to see? Something here, somewhere. Whoop. Oh my god. Somewhere like 10 millionth checkpoint. I mean, it's okay, right? It's not. It's only okay. Nine 540 checkpoint. 9540. 95. What happened here? The episode length was very low. Oh. Okay. I think I understand what's going on here. All right. I don't think PPO on its own is gonna get us. I guess what's interesting here, it's that it is indeed walking, and the observation space has been trimmed. So this is great news. for us. But all right. Anyways, we'll continue tomorrow.
Day 2.
Hello. Next day now. Yeah, just getting started. Let's check TensorBoard. It ran overnight. It's still running actually. The other thing is like I accidentally. Oh, my camera froze. My camera. Okay. I accidentally tweeted about this whole URDF not handling forward per linkages things. I thought I was tweeting in a community, like in a small group, but it tweeted publicly, and a bunch of smart people weighed in. Apparently, it's a thing. It's a well-known thing that URDF just sucks at linkages, and some people wrote some kind of like workarounds, mostly about using inverse kinematics, like Clayton's saying here. Some people are like, why don't you just redesign it so you don't have linkages? I'm actually very tempted to just redesign it so it's mechanically simpler and easier to model. Directly find it using SDF if using Gazebo. I don't know why anyone would use Gazebo. Like, you don't want to use Gazebo, but SDF, it's an alternative format to URDF. And it's also the Syrian forces, but SDF, I don't know what it stands for, but it's basically an alternative. So I assume SDF and Gazebo are somewhat related. I guess SDF is the URDF of Gazebo. This guy switched to MuJoCo, didn't say how. He references other Onshape to Robot library. So you go to Onshape to URDF to MJCF, which is what we were doing before. This other library is the other library that exists other than like the K-scale one, which is what I want to try now. And so he said there's a Onshape to MJCF tool is gonna come out soon, but he didn't say who's building that, so that's interesting. Yeah, seems like a lot of people have dealt with this. I'll find an answer to this too. Yeah, which is, it's crazy to me that this is the state of robotics in 2024, you know? It's like, that sucks. With LLMs, like, as soon as GPT-3 had traction, we had like LangChain, you know, and it was like all these utilities built around it that we didn't really even need, but it fixed all kinds of issues, even things that were not actual issues. In robotics, it's like every time you do something, you get slapped. Like, nothing works. There's like some small catch somewhere, everywhere. It's really unfriendly. I'm constantly shocked. Let's see if this guy who owns the other Onshape 2 robot repo has something for us. I guess, yeah, I don't know why that guy on Twitter said, yeah, not really. We can try this library just as a replacement to the K-scale library, because K-scale wants you to find limits on the Revolut mates, and I don't understand why. But first, let's take a look at this LangChain stuff. So I'm just gonna refresh here. You can see here on this line is PPO. It basically has flatlined both on reward. Actually, reward is going down slowly. Reward is not even at 300 here. It's pretty poor. The episode length has flatlined. And then let's try to smoothen these things out here. Smoothen these things out. All right. It's fully smoothened here. Looks like, you know, first of all, the TD3 reward continues to go up almost like linearly. SAC start to go up. Episode length for SAC is going down. Episode length for TD3 is going down. So let's evaluate some of these things. Let's see what they look like. All right, so let's do Python evaluate by Pedal. I'll go SAC, and then I don't remember. What's checkpoint? I guess checkpoint. Um, this is SAC, so the latest checkpoint 360 3,360,000. Let's try to see what that looks like. Whoa. All right, forgot to move. Did I make a typo? Did I miss a 0? No. Wait, what? That's so bad. Yeah, that's really bad. I guess I smoothed it too much, and it's actually very noisy. Okay. We want. Okay, this one's getting better. Yeah, I mean it's not bad, you know. It's kind of works. Again, the cool thing here is the limited observation space. There's no lidar here. There's no contact flags on the feet, and there's no actuator speed, just position. It's basically position and IMU data. Actually, let me run something here. Let me run 2 million. Right, so this kind of like gives me hope that yes, we don't have to add more sensors to a robot. Like that's not how I want to walk, but it did solve. Yeah, like I'm just trying to imagine what these would look like in real life, and it feels like that would be kind of tough on the actuators. Anyways, let's check TD3. Checkpoint. Yeah, checkpoint. Continues to improve. Nice. 4, 6, 99, 0. See that. Okay, very tippy-toppy. Some body tilt. We don't reward for keeping a pitch 0 on the body, on the hull, which in real life I might. But that's interesting, right? Like the walking sequence, the gait is so much different. It's like very small steps. Probably less robust to like, you know, external forces, but you know, that wasn't part of the reward function. So, I mean, that's cool. I don't think we need to keep running these, right? I think that's cool. You know, I'm kind of done with all the 2D stuff, to be honest. Let's just make 3D work. So I'm gonna finish all of this stuff here, and I think that should free up our course. Yep, I killed tensor board. Oh yeah, are they still running? I think my terminals are all done. I mean, not the nicest way of killing the process, but CPUs are still hot. Oh, by the way, I was looking at this exobody to GitHub. I don't know if anyone's seen this. Looks cool, like another humanoid. Very robust controller, I'd say. Like, I mean, I don't know, I think it looks good. I think it looks good. It's still like, yeah, I think it looks good. Always a question of like, how is it to teach it to do things, you know? That's kind of like the big unknown. There's so many labs working on it, but anyways, all right, so now we can focus only on this MuJoCo thing, right? So I'm gonna close all this stuff. It doesn't matter anymore. My API keys, try to copy those. I want to change them anyways. RL learn, MuJoCo, and then I think we're working within Onshape. Right, okay, so where we left is we built this URDF robot assembly. We have all the correct mates that the K-scale library liked. But then we run into this issue where URDF doesn't like any loops, closed loops, kinematic closed loops, and that includes a four-var linkage, on which we happen to have two of them here, another one here. Now there's a bunch of workarounds. You know, we could remove the four-var linkage out of the environment because we kind of like don't need it. We can based on these legs position, I can already estimate the actuator's actual position, right? So we don't need it, and it actually adds more complexity because it has to simulate more elements. It has to check for collision, the meshes here, and so on. So we could remove them, and I think gain computational advantage and so on. It just feels a bit lazy to me. It's like I just want it to actually work the way the way I have it here. So I'm gonna try to avoid removing it. Although we did check, I think what the Stanford paper did, and they did remove these four-var linkages from their simulations. And then there's other. Well, actually, I don't think there were any other suggestions that were good. But what I wanted to try was basically don't remove the four-var, just break one of the mates on each four-var, and then we'll rebuild that mate. Break it. Okay, generate the URDF, and then we'll rebuild that mate, that missing mate, on the MJCF file. So that's what I'm going to do right now. Now, there's two ways to go from this broken four-var model to URDF. One of them would be using the K-scale library that we were using yesterday, which is this here, on-shape to URDF from K-scale. Of course, the issue here. Actually, let me switch to light mode. The issue here is that for some reason K-scale asks you to. Where is this thing? Wallpaper. Where would you put this? K-scale wants you to. Oh my god. Dude, appearance. Light auto. All right. K-scale wants you to set limits on the revolute mates, min and maximum. I assume that's because that's very relevant to their humanoid robot. That's not very relevant to what we're doing here. That's my assumption. Perhaps there's a good reason why they've done it, and we're gonna figure out downstream. But right now it's very limiting, so I don't want to be limited by that. So on shape to robots is the other kind of like popular library here. Let me close this stuff. So this stuff here, and so we are gonna try to use these. All right, so there's just quickly going through docs here. I don't know if it makes sense to talk my way through these. I'm just gonna do it. We're gonna be here together for the next 4 hours or so. So buckle up. All right, what is this? Well, I guess wearing a YC sweater, but I got rejected by YC, by the way. Not selected for my Robots Entertaining Humans application, which is what I posted on YouTube. This is the 4th time I get rejected by YC. So my ratio is gotten once, rejected 4 times. So 20% success rate. Yeah. Anyways. All right. OnShape is a tool that allows you to support. Yep. I'm pretty sure I already installed this stuff. Let's put it here. Yep. Yeah, easy. Commands. Run checkers. All right, looks like we need to create a config JSON file. I see. All right. Gonna copy these. I think if I read that correctly. Okay. So that number there. Once it's done, on shape. Okay, let's see. On shape to robot. My robot. Let's see what error it throws. Obviously, oh. How can I export all of the contents of .m from my let's see, source.m, using export m. I always forget these. Not used to it. Not used to streaming stuff, you know. I normally would just freaking do it the dirtiest way possible. No one would try to steal my API keys. Oh my god. Alright. Like I said, I'm gonna nuke all of this on-shape stuff, so try to steal it. Have at it. Oh. I don't think that worked. No. Oh, I see the issue. All right. Now it works. Now it's gonna work. I was just on the wrong directory. On shape to my robots. All right. Adding sequence. Things are happening. Writing URDF file. Okay. So it appears to have been successful. We have a URDF file here. How do we know? I wonder if this is a PyBullet. Let's actually check the docs. How do we know if this was successful? Export your own robot, handling kinematic loops. Oh. Interesting. Okay, here using OnShape to OBot. Is that a typo? That must be a typo, right? Adding frames. However, this will require manually 2 frames at position. If you okay. It's not entirely clear. It looks like there's no PyBullet command there on that library. So let's see if we can use the Kscale one. My robot, what do you already have? Just to see what it looks like. It's in there, so it seems to have worked. Trying to I mean, that's just a servo. That's just a servo. Let's look at the meshes. Oh, I guess it literally is only a servo. So let's see what went wrong. Did I have the wrong something? URDF robot. I probably missed something here that I was supposed to do. Once you install, oh yes, config entries. Here's the full list of possible entries in this configuration. Yeah, whatever. Assembly name. Optional. The first assembly found will be used, which is correct, right? Like the first assembly found should be this one. So okay. Why did this not work? Run it again. Check open scat whatever. Check in mesh lab. Okay. Workspace ID. Yeah, sure. Return element. Okay. Found assembly. What is assembly? Why did it? Okay. Anyways, I'm gonna specify the assembly so this doesn't happen. Assembly name. I mean, right off the bat, honestly, the K-scale stuff was working better. But if this gets us to the final state, then I'll be happy. All right, let's see. Trunk is port 1. All right. Port 1 has no mass. Maybe we should assign material to it. Genius. All right, now we're pulling the right meshes. We're missing masses on a bunch of stuff, you know. It's interesting that it proceeds. It flags a mistake and it proceeds. On the K-scale library, it will just stop. It will just not proceed. So. Part of me feels bad about how long it's taking us to just get this inside the sim. Just get it inside, you know. It's not even like training anything to work. Nope. Just getting it inside the sim. Now let's look at it in PyBullet. That is the complete thing. I mean, the 4-bar is there. Okay. Oh, we appear to have no joints. I can't rotate. I'm rotating now. We appear to have no joints. So the joints are broken. It's a solid. Interesting. All right, we're gonna need joints. So why didn't the joints not work? I guess back to reading some docs here. Commands: unshaped robot, import robot, unshaped robot, edit shape, edit impure shape. No. At running bullet. This is your robot. Oh, okay. So there is a PyBullet thing built in here. Okay. Well, let's try that. I mean, it won't. It should be no difference. No different than what we just did with the K-scale stuff. It's asking for center of mass, I think. This lacks so bad. Center of mass. Oh, it's calculating. I think it's calculating center of mass. It's printing the center of mass. All right. Anyway, same situation here. We appear to have no joints. We can look at that URDF to try to figure out why that is. If I can find it, of course. Big if. It's probably right in front of me. Just can't see it. Here. All right, I'm gonna ask the AI to take a look at it for me. Are there any joints? And then meanwhile, I'm gonna design time considerations, specify degrees of freedom. This seems relevant. Degrees of freedom should be a slider, cylindrical, or revolute. So if you remember, K-scale did not support cylindrical. This one does. and it seems like it wants us to name the mates. So that's what they're not importing. And that's why this file does not contain any join elements, because we didn't name our mates. Our mates are not named. If you go here, our mates are just not named, right? So, so we gotta name our mates. That seems fun. That's very easy and friendly. Let's name our mates and see how it handles 4 bars. All right. Degrees of freedom should be a slider named DOF something, or something will be used to name the joint in the final document. If the mate connector is cylindrical or revolute joint will be issued by default. To make a continuous joint, add continuous or will in the name. Oh. Okay. For instance, let's see. If the mate, okay. Well, what happens if it's not continuous? Huh? What happens? What happens then? Yeah, so in my mind, we can do, all revolute joints can be continuous, and then the model can make sure we avoid collisions, right? So I think that's computational intensive because you have to calculate mesh collisions, but in theory you can do that. And I don't know if I'm gonna regret that. So all my stuff here, shoulder, rear, right. So for example, that'll be one name. I put revolute here, and then rear right, and then in theory, if we do this again, yes, I know I'm missing some masses. Thank you. I know it's kind of slow, to be honest. Alright, not that slow. Alright, so in theory, now I have one. Yes, I have 1 degree of freedom. Success. Very nice. Now this is buggy. Oh, we crashed. I don't know why. I don't know why this is so laggy. I know if you turn off the graphic user interface, it's less laggy. Okay. Okay. So now in theory I can move these, and it moves. And I guess it's in radians. Yeah, radians. And I didn't say continuous, so it's limited, but it's limited in a range that I didn't specify. So what happens if I specify a range on shape? Sorry. So so limits here. So I mean 0 to 90, something like that. Oh my god, that's bad. Oh. What about now? 0, 180, something like that. No, that's not 180, dude. Can this thing even go 180? Alright. Well, let's set that limit. We've set that limit 0, 180. Obviously, we'll never go 180, but I'm just checking to see if the limits will translate. I mean, so far this library seems to be pretty good. Okay. And then we open these in sim. 180 in radians is like 1.6 or something like that. So, right? Right? It's the beauty of doing math in public. It's like, oh my god, it crashed. Doing math in public is great because obviously everyone watching has that insight of being able to calculate things slowly, and then you just look dumb. Okay, please don't crash. Just don't crash. Don't crash. Okay, all right. 0 is good, and then whoop. Okay, that's completely wrong. Okay, so it doesn't handle limits well. All right, let's just put it that way. It doesn't handle limits well. Please stop. Please stop. Stop it. Stop it. Stop it. Okay. Now, why does it suck at limits? Well, I don't know. But that's good to know. That's good to know. So I don't care for these limits anyways. But now I know that it's a waste of time to actually put in these limits. All right. Anyways, now let's put on more degrees of freedom. So here we have revolute. This is rear left, and then this is front right, and then this will be front left. And let's just see how it handles more degrees of freedom. Meanwhile, let's look at the docs here real quick. Inverting axis orientation. When doing this connection, click the children joint first. This will be used to find the trunk of the robot. Okay. I wonder if I mean, I did those yesterday, right? So I don't know how I did it. Let's just hope everything's good. You can invert axis orientations. Probably not needed. Why would you ever? Naming links. If you create a mate connector and name it link something, this link corresponds to a part of just that. The link corresponds to a part. What's a link? Adding custom frames in your. Okay, this could be useful. I guess I don't know what a link is, and frame is an axis. I guess here's a link to can we use a frame. Okay, well I don't even have a need for that right now, but it's good to know. Okay. This is supposed to have more degrees of freedom, but it seems to have failed. Oh. The legs didn't import for some reason. I wonder if I did something wrong. DOF shoulder front left. Does it think they're all named the same or something? Disabling open source. No. Warning, joined. Has no limits. I am aware. I'm aware. There's no limits. Because you don't respect the limits, so what's the point? Part 1 has no mass, whatever. Writing, okay. So other than part 1, okay, why? So this should work, right? And it doesn't work. And it does not work. I'll put it here just so you can see, but let's look at the ERDF for shoulder, rear, left. Oh, I see. Interesting. Why not? So I have a little theory here. These all should come up. Like, right? You think that doesn't matter, but we're in like try everything territory here. That didn't matter. Okay, it's only important in one joint for some reason. I don't know why. Docs, please export your own robots, whatever. I think that's all fine. We can close that. Degrees of freedom should be sliders and call yes. Yes, to make continuous, shows add continuous or wheel. DOF, front, left, okay. Perhaps I didn't click the children join first. Whatever that means, right? If we observe, so this one works. And I first click whatever that is. And then edge of the rear servo box, right? So I click the orange part first. And then I clicked on the servo, question mark. And then on this one, I first clicked on that's still the servo box. Okay, so that's not it. What if it doesn't like the names convention? I don't know. It's like I know how dumb this sounds, by the way. But I'm like, yeah, that could be it. All right, let's try that. If this works, I'll have no idea why. It's not actually throwing any errors or anything. Okay, cool. It didn't work. Let's actually try one more thing. Actually, let's look at the errors here. Joint, right? So it first of all, it recognizes there's 4 joints here. Found 4 DOFs. Right? But then on the final robot file here, actually, am I screwing this up for having the file open? Is that a possibility? Just maybe I have autosave. No. Yeah, yeah, this is incomplete. It's an incomplete export. Okay, but why? We're doing so well. What happened? Robot URDF joint. Rear. Let's check the meshes here. Rear right leg assembly. I am not sure. See, when I had less joints, it was working fine. Is there a limit on joints or something? Obviously not, right? Token ID, child link, click first, parent link, okay. Silicon mate, name DOF, underscore. Dude, I don't know. these all look the same. Looks the same to me. That's so weird. What am I missing? Update all the documents, whatever. Okay. Right. What am I missing? Tell me. What am I missing? Oh, no. Okay. Anyways. Okay, adding parts. Adding top level instance, rewrite like assembly. So it added that trunk is, okay, so this is incorrect, right? I don't know what it means by trunk, but the fact that it thinks the trunk is the servo, it's incorrect, right? And it makes reference to it here. First we'll use the trunk. What the hell is the trunk? I don't know. But obviously right now it thinks the trunk is the servo spaced here, and that's not the case. What the hell? What's the trunk, Doc? Tell me what's the trunk. Let's see if there's anything on trunk. Configurations, mess up file names. Help select configuration. Oh, okay. See, this guy is complaining about something that it's probably because all right. Anyways, I'm gonna fix my stuff first, and then I'll help others. So I think the issue is that it thinks the trunk is the servo child parent link, right? So I guess the issue here is that the servo is kind of the trunk, but the servo itself is part of, like, I don't want the servo in the trunk. The servo is part of an assembly that is the trunk. So we need to, I think we need to create another assembly here. I'm gonna call these basically, well, okay, first, I think this is the cleanest way to do this is this. So, torso assembly, you already have torso assembly. So we go here and we basically remove the legs and this is the trunk, and then here we remove everything that is just not the legs, right? And so here, and now we insert this assembly, and I know this is getting a little kind of weird. Where is it? You already have torso assembly. It's getting a little weird. Can we fix this, please? Fix it in place. Fix it. What is this? Has degrees of freedom. I know. Don't want it. Don't want that to be true. What's this? Has. No. I know this is getting kind of out of hand, but I think this is how it works, or is supposed to work. Why can't I fix it? Nothing works on shape. Jeez. Anyways, and now we add 4 jump mates here, and I think that trunk will be here, and that's correct. So if we go here, remember child link is click first, and then the parent link is this. This will be the parent link for all these guys. So we create Revolut mates, create them here, very clean. First the child, then the trunk. Okay. Bam. All right. Yes, I know I need to clean the name, right? Shoulder, rear, right, something like that. Dude, why can't I fix things? Are you trolling me right now? Rage it? Fix it. Normally you can right click and fix things. All right, anyways, OnShips is trolling right now. It's okay. It's all right. OnShips is trolling. Can I fix this? No, of course not. Anyways, OnShips trolling. Do not engage the trolls. Do not feed the trolls. Click here, and now the trunk or whatever. First the child, then the trunk. This is like when you're in a plane, and first you put your mask and then the child. This is the opposite. First the child, then the trunk. If this doesn't work, I don't know, man. I feel like I'm going above and beyond here. Like the docs didn't say any of these. I'm like using my poetic freedom to try to figure out what they actually want, what OnShape wants, what the, oh my god. This is a family-friendly channel, so I'm not gonna swear or anything like that. But why can't I frick? I do not understand. Why can't I just log that? But anyways, I digress. Let me nuke this stuff. Nuke it. Don't need it. Just trash. Put it in the trash where it belongs. Alright, error can be found. Okay, regrets. Immediate regrets. Alright, just do it. Just do the thing. Can run it. Alright, so first. Oh my god, I forgot. Of course, I forgot to name my joints. If you don't name the joints, they might as well not exist. You gotta name the joints, man. The joints, how are we gonna know there's a joint if you don't name it? Alright. 4 degrees of freedom, that sounds good to me. The trunk is you already have torso assembly. Yes, that's correct. And then this should work. Easy. It really just works. It's like something Steve Jobs would have made. And now you can see here we have 4 legs. This is probably gonna crash. It crashed. Sorry, my bad. It's my fault for not having a better computer. Honestly, really pushing these MacBook Air. I don't even know what you need to run Pivolit. Like, do you need GPUs? Can we like, isn't it optimized for Mac, Metal, whatever? Oh my god, it keeps crashing. Alright, I'm just gonna let it hit the ground, alright? Just let it hit the ground. Don't look at it. You can look at it. I won't look at it. I'll put it on the side here. I'm not gonna look at it. You can look at it. I'm not gonna look at it. Anyways, it would be really cool if this was fixed. Oh, it still crashes, man. Who comes up with this stuff? Dude, stop crashing, man. You're embarrassing yourself. Anyways, so I think that'll work. The thing is, now we have to repeat this entire process for the legs, the sub-assemblies and the legs. Yeah, because I think that works. I don't know, Pybullet, unstable in Mac. I'm gonna ask ChatGPT. Pybullet keeps crashing in my Mac. Is that normal? I have a MacBook Air M2. Yes, unfortunately, that's not unheard of. Pybullet is options for Mac, especially newer M1, M2 chips. Bro. I wonder if I can tell this thing to not run. Not run the GUI. Maybe someone has figured it out. JK, probably not. Whoop. Okay, onshape to robot with no GUI. Okay. Current onshape to robot command found. Also, oh my god, no, come on, onshape to robot. Yes, oh, GUI, no mention of GUI. GUI. What's a usual CLI command? CLI command to turn off Pybullet GUI. Let's try to see here. Help. I'm gonna call. Just 1 sec, I'll be back. Yeah, I got a call from an unknown number, and it's like, how do you know if it's important? I always Google the number. It's like, no clue who this person is. Some HR lady. I'm like, bro. Hopefully she'll email me or something. Anyways, trying to run this without the GUI. Fix no self collisions. What is what's the ideal hardware to run Pybullet? Do I need a GPU? Oh, okay, so Pybullet physics engine CPU based, I guess. So it's only Macs that have issues? No. Fikit? Oh, cool. Huh. That is not it, right? Yeah, this is it. Uploaded to Pocket. Running PyBullet, not crashing PyBullet on Apple Silicon. Okay. I don't know. Is PyBullet just bad on PyBullet Mac? PyBullet Mac. PyBullet Mac. They give me completely useless stuff. Okay, this case. Okay. No GUI. I don't know why he created a different repo for examples. Seems kind of useless. Can I run this repo with the PyBullet GUI off? Okay, what if I run my own custom PyBullet mPy? Okay, I have a URDF file in robot.urdf that bro. I can specify the file path, and I want to write a Python script to open it in PyBullet with the GUI off. Can you help me with that? I'll just write my own, I guess. And by I will write my own, I mean the AI will write me one, of course. It goes without saying, right? Okay. Oh. Yeah, put it here. Move here. Yes. Let's see. Cannot load the URDF file. It's because the relative path is wrong. Try again. Somehow this is even slower. Wait, so I need to be able to see the sim. I can't see it right now. We must render it, but without the UI. If that makes sense. I'll help you modify keywords and color visualize client group options, background color. A lot of stuff here that for context, I am on Apple Silicon MacBook Air M2 because nowhere they did reference metal, but maybe it's like just like okay. Alright, see, so now it doesn't crash, but I don't have to GUI to like, oh, it didn't crash, it just, run out of steps here. Now it doesn't crash, but I don't have the GUI to make the joint smooth, you know. But that's it. Alright, cool. I don't need any of that. How can I make the joints smooth? Oh, it's gonna make them move. Well, let's try it. I think like that's not it. Honestly, this is a side quest. We don't actually care. Okay, yeah, legs are moving. Anyways, yeah, that seems fine. We don't need any of that. Okay. All right, well, now we need to. It's just funny that I can't fix things. So. Oh my god. Yes, yes, on shape. That's what I meant. Thank you. Why can I fix it? On shape, fix, assembly. Right click apart from this. No, are you? Oh, yes, of course. Yes, 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 of course. Oops. So you cannot fix an assembly. You can fix a part in the assembly. Of course. That makes so much sense to me. Yeah. All right, perfect. All right, so we must continue now and do the same thing for the legs. You gotta get a drink. Okay. All right, so I guess we're almost there. I mean, moment of truth here is figuring out how it's gonna handle, how this new pipeline's gonna handle a 4-bar, right? So this one's much more interesting because we have many more joints to actually name. And so things like this little guy here, right? So DOF, knee, wheel, or continuous. Continuous, did I spell that right? Continuous. I did not. What the hell is this spelling? Is this American? It is British or American English. It's both. I'm just wrong. I mean, English is not my first language, so. DOF. What do you want to call this? Linkage 1 continuous. DOF hip continuous. GOF linkage to continuous. Wait, actually, this who said hip? I guess so. I guess hip cam. DOF knee servo knee continuous, and then DOF servo hip continuous. Actually, these servo ones are not continuous. I know that much. We have a couple more here, but they are suppressed. Let's try these. Not these. There's a JSON config file here. So we're gonna try config. This is gonna be our actual config, and we're gonna put this here. Actually, I think it's the same. Yeah, it should be the same file name. It's just the assembly name here will change. All right, so now we can run. This 6 degrees of freedom. I didn't count, to be honest. I believe it. 1, 2, 3, 4, 5, 6. Run this. What do you notice? Okay, first thing I notice, it's very hard to rotate. I think I got it now. Oh, jeez. Okay. Oh my god. Alright. That is only the servo. Oh. Okay, I see what's going on. Do you see what's going on here? Only the servo stuff came. It probably thinks the I mean, I didn't read it right. It probably thinks the trunk is the servo horn. Trunk is a servo actually. Yeah, great. Gotta deal with that now. This is very annoying actually. I mean, if it thinks the trunk is these, why did it import these and these? But I guess not these, because those are fasten joints. And fasten joints don't count. How does it handle fasten joints? It's a joint. It should be a joint, fixed joint. I don't know if I understand why. There are no fasten joints. There are no fixed joints here. But there are fastened. Am I supposed to name them something actually? Okay. So it does say if it's fastened, joint type is fixed. Why does it matter what is the trunk? I mean trunk as in like the trunk of a tree trunk, right? What will be the trunk here though, right? It's like, I don't know. Basically, things that are fastened together, it might as well just be in one assembly. And if that's the case, the trunk would be these servo blocks with these servos here. But then there's stuff like these. I mean, I guess we would eventually get to it. I just don't get it. First features can't find the OFs. Alright, so it finds the correct. Let's run it again. It's very annoying. I think I get it, but no limits, whatever. You don't respect limits. 60 OFs. The trunk. Building the okay, so it builds a tree. So from the trunk you have branches. Right? So the trunk is at the bottom. And from this bottom you can have top level instances that connect to it. But only dynamic joints. Right, so I do think that what makes the most sense here. Actually, let me look at all the. Okay, so we have one fasten joint here. Huh. I mean, we can try it. It's just gonna be a lot of work, especially because there's so many legs. And it's not like this is some best practice or anything. Let's see, what's the most lightweight way of doing this? Can I create an assembly within this assembly? Make axle selection, create empty subassembly. Okay, right. And then I call these. Can I name it? Bro, let me name it. Servo box. Right. So now this guy, the knee horn, show mates, yes, here. The knee child connects to these, which is actually a servo box on its own. Which is, sorry, it's an assembly of its own, so. Okay, right? Trunk is servo box. So we went a little further here. Let's just visually look how much further we went. This zooming part sucks. Okay. All right. So what's the expected behavior here, right? Include all for revolute mates, right? It's except from here to the upper, the leg upper. That's actually another fastened joint. So anything that's fastened joint should be on its own sub-assembly, basically. Which is it's who came up with this? Who came up with this? Actually, let's. Can we make sure when this starts, we are zoomed into the robot? I mean, I understand the logic now after much trial and error. The logic is not laid out anywhere, and the logic is kind of dumb. But I don't know. Maybe there's a reason for its logic. Maybe I'm missing something. I think the logic is dumb. That's my opinion. Let's see if I'm wrong. Like upper. Safe. All right. Now we gotta make sure. I guess that these thing here. Show joints, show mates, submate, joint right box lower, yes, child, okay, yeah, that's probably good enough. Mhm. 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 Push rod, like upper, lower simple. Okay, that might be the entire thing. Is that the entire thing? Pretty much, right? I mean, actually, yes, 100%. That is the entire thing. Not missing a thing. First time in a while. Oh, why is navigating so weird? Okay, cool. At least I think that's correct. Now, basically, gotta do these for all the legs. And then the other thing is, can we make it so by clicking and dragging my mouse on a part of the robot in the sim, I am applying a force? This should be doable. I'll help you. Okay. This seems too complicated, to be honest. That's basically all I was expecting. I don't know what's all this other code. I don't know what this is. It's complicated. Let's try it. Can we just keep it simple, please? Okay, let's try it. The AI special. I'm dragging it. It works. Okay, that rotates. The other one doesn't rotate. I mean, joints are rotating, so that's good. Setting joint frictions and stuff is also a thing, which we haven't done, right? So, like you would expect to lift the leg like that, and then the leg would extend. The leg would extend. The leg would extend. No, that's an extend. But I think the degrees of freedom are there. And sure, the physics could be tweaked a little bit, but you know, that makes sense to me. Anyways, that's cool. So we kind of like just need to fix the rest of the legs now. I'm gonna make a protein shake. I'm getting hungry. I'll be back in a sec. All right, I got a little distracted here, but we're back. I guess the next thing was to do the same thing for all the different legs, but there's one more thing we can try. There's two more things we can try. First, we can bring back the full 4-bar and see if URDF will handle it. K-Scale said no, and I mean everyone else has kind of said no. So like everyone on Twitter was saying like URDF cannot handle these. But let's try it. Let's try it. I want to see it for myself. DODF linkage for continuous. Let's see what happens. Let's see if it throws up an error or something. Error is continuous. That is already connected. Yep, that's the error. Okay. All right, so indeed 4-bars do not work even with this library. We kind of like knew that already. We're just testing the waters. Anyways, the other thing I want to test is now that we have these like assembled and it works as a leg assembly, what does that look like at that higher level assembly, the entire robot, right? Do the leg joints work at the top level or do they not? Let's try that. You can tell the inertias here are wrong. Oh, I mean, I don't know if you can tell. I can tell. It just doesn't handle the same way as in real life. I think the servos are too heavy. Like their material is set to steel or something. All right, I'm gonna rename this stuff here. Copy. Config. All right. Okay, a lot of parts, and let's try it. All right, so this is the top, the whole body, and I guess the rear right leg should be this one here. Should have joints. Doesn't look like it wants to move. Actually, looks very stiff. Why is that? Yeah, why is that? Oh, wait, actually those are shoulder joints, of course. We do have shoulder joints. Okay, so something else might need to change here. Also, these shoulder joints are very stiff. But anyways, let's look at the URDF file. How many joints are here? I'm gonna ask the AI, but I'm also just gonna take a look myself. There's not that many joints. Oh wait, actually. 3 joints. We broke 1 joint, that's why one of them wasn't moving. Remember, child first, and then trunk. And then name this but anyways, in URDF, so I've created a URDF of my top level assembly in Onshape, but there are sub assemblies that they themselves have joints. How should these be handled? So maybe this library we're using can only handle 1 level. Yeah, we need to flatten the hierarchy. Oh, man. Okay, all right. So what that means, I get it. I just, man, that's so much work. I mean, it's a lot of work for no particularly good reason. So it wants that flat hierarchy file. Man, that is kind of dumb. It's gonna be the amount of clicks that it's gonna take. It's a little silly. It's like, it's a lot of clicks, man. Should we just do it? Should we just get started? Spend the next couple hours doing this? I mean, I guess. What are the options? Go back to K-scale. Because I think K-scale was able to handle some hierarchy. I mean, obviously they have hierarchies, so. Right? So obviously it doesn't have to be completely flat. Kind of like the only downside of K-scale was having to set limits on our revolutes. But hey, maybe that's not such a big deal, you know? Let's let me see what this looks like. Oh yeah, true. It wants me to break the it wants me to break the 4 bars, which it's completely okay. It's fine. Let me just visually break them so I know which ones are broken, and we'll break them all in the same spot, so it's very easy. I guess the other advantage with K-scale is that I don't have to worry about naming convention. I can just do whatever I want. Yeah, the limit thing is kind of weird though, but I don't know. Maybe there's a good reason for it. I mean, the thing is, everyone wrote their own libraries for their own use case. So maybe I should just write my own for my own use case. But the use cases seem to be very geometry dependent, which, you know, you kind of like don't want to write a new library every time you change a geometry. That makes sense, right? Seamless connection for your FX requires some power connections. Rear left. Wait, are you sure? I thought yeah, are you sure? Dude, I thought I thought suppressing was fine. I mean, we can delete them, but I thought suppressing was fine. Was it not fine? Yeah, it's fine. Yeah, missing limits is a different story. An even more annoying story, but it's a different story. Or is there another parallel? The assembly has 5 parallel connections. Rear left, upper. No, I don't think so. I think it's just not updating correctly. Let's try it again. The issue here should be the join limits, not some parallel connections. Yeah, there you go. Oof. Oof. That's a lot of joints, man. Sheesh. All right, so we can fix that. Somehow that feels easier to fix than. I don't know. Like, why would you rather fix that or flattening out the entire thing to one file? I guess fixing that's easier. Also, K-scale also makes the MJCF, not just the URDF. So for that reason, I would rather deal with the joint limits. You can be the judge if it's a good reason. Man, I am freezing. What's the thermostat at? 70? Don't mind me. It's very cold in here. Anyways, all right. So we're gonna find some limits here. Limit. Or 0 to 180. No. Sure, I can deal with that. Limit 0 to 180. No, dude. No. Yes. 0 to 180. Okay. So this one's done. I'm just fixing this for visual purposes, but all right. So when we run this again, we had 27 errors. So this time we should have 23, and now we have. We still have 27 errors, which I know is wrong, so fix it. 23, only 23 errors. There we go. All right, cool. 23, and then each leg has what? Like each leg has 5.75. No. So I don't know. We'll fix the issues. I'm gonna go to the bathroom real quick. Okay. Let's see. Rear right leg. That's always what we play with. So we have 4 joints here. Oh no, actually we have more. 1, 2, 3, 4, 5, 6 joints. That somehow we need limits on. I'm gonna completely make it up because I have no idea how you could potentially how you could possibly put limits on these things. So yeah. I don't know, man. I don't know. Whatever. 0. Boom. There you go. Limit. Yes. Now that has a limit. This guy here. Oh, fuck. Oh, sorry. This I'm gonna put limit, no limit, right? I'm just gonna test if that triggers an error. I think it does. So 6, 5, there's 5 errors if that triggered an error. There's 4 errors. Okay. Servo hip. What's the name of that limit here? Servo. Linkage to continuous didn't trigger an error. Interesting. Wait, what? Really? So if I set the limits to no limits, there's no errors? Can't be that simple, huh? OnShape is really weird about the limits, right? It's like things start to contort. It's like, I definitely don't want that. Like, I don't know what it thinks these limits do. Which is really weird. It's like, I don't want you contorting. Yeah, see, like, why? Why did that happen? I have no idea. Okay. So now everything has a limit. Wink, wink. Limit is no limit. Let's try that again. DOF need continuous. DOF need continuous. I messed this up. Everything has a limit now. Wink, wink. No limit, but okay. Okay. Seems to be working. Warning. Geom with duplicate name encountered. It's a warning though. It's a warning. Warning don't matter, right? 30F. Let's open it and see what it looks like. Oh. Where's that name coming? No. Weird name. Alright, so this is what we have for just the leg, I guess. Physics seem fine. Right? Wait a second. Stop it. Right? It's kind of like how you would expect it to swing. That is not how I would expect it to swing, but the other one is swinging that way too. Yeah, okay, not that way, so that's fine. The inertias are wrong, but okay. Alright, so that seems to work. So instead of actually caring for limits, we can just set the limit to everything to no limit. And that seems to do the trick. Of course, OnShape likes to contort, like the Exorcist or something, but I'll just do that all around. Easy peasy. Revolute. Of course, we still need to figure out how to actually eventually we need to fix the broken 4-bar on text, which honestly it's probably not that hard. I don't know why no one on Twitter suggested that. I mean, I might be missing something obvious. I always assume that, you know, I must be missing something obvious. I always assume I'm the biggest noob. Everyone else knows better. I must be missing something obvious. Revolute. I'm gonna eat chicken tendies today. That's what robots are built on, chicken tendies. Limit. Okay, one more. Man, I've drunk too much Coke. So you should buy soft drinks. I just drink all of them in one sitting. It doesn't matter how many I buy. I buy 10, all gone in one day. I buy 30, all gone in one day. I can't limit myself. And Costco sells packs of 35. I have 2 of them, so I have 70 right behind me. I could potentially drink 70 cans of Coke today. 70 cans of Coke, each has 355 milliliters. That is 25 liters basically. Which I don't think it's doable, right? But then I say that and it's like starts to feel like a challenge, so I'm like, oh, but what if it is? You know, it's like, but what if it is doable? All right, let's try this. This should work now. I mean, everything except the broken 4 doors. Whew. Oh. Bunch of warnings. I am not sure why I'm getting these warnings. Okay. So that's a robot right there. I don't know if the legs are actuated. Oh, I guess the legs did move. See, okay, this leg is stowed in, right? So if I twist it around, it should come out. It did move, right? So the joint frictions are probably wrong, but I think the URDF geometry is correct. How many joints, right? So we didn't have to flatten it into one spot. K-scale is better at handling. Oh, there you go. All right, lots of joints. So now we have our MuJoCo file here, right? So this is what we're looking for. I guess the one thing that's unclear is what needs to be rebuilt on the 4-bar side of things. I'm gonna ask what specifies the friction of a joint. Joint. There's no dynamic though. URDF effort. Oh wow, what is this form? Oh, ROS answer. ROS answers. Lower, optional, default to 0, upper. They are documented here. Let's see. Oh, is this from ROS? URDF. Oh, ROS org, ROS URDF. Yes. Wait, I guess XML. Okay. Okay, interesting. I didn't know URDF went back to ROS. Effort. Why are you like these? Why are you like these? There's no mentions of effort. Effort. Showing elements. You see it? Why is it not showing this? Tools URDF. URDF. XML. Isn't this the same thing? XML? The package. Oh my god. Effort. An attribute for enforcing maximum joint effort. Okay, maximum joint effort. So it has nothing to do with friction, right? That's like how much torque. Effort velocity. Upper. Lower upper 0 0. Velocity. Maximum velocity. Okay. Dynamics. Optional. Defaults to 0, so it should be 0. Why is it so stiff? Okay. So everything defaults to 0 basically. What else do we have here? We have joining, origin, parent, child, limit. Axis type, that's it. Effort 80. Effort. In Newton meters. Yes. Okay. What about MJ's? Okay. Anyways, I don't really care about the URDF. Let's see what MuJoCo has. Inertia. Okay. How many joints are here? I know I know already that we counted joints, but what defines the friction of a joint? MuJoCo is joint several parameters that can be defined in default section. Joint limited, true. Okay. Armature. Okay. I want to modify this code to open a MJCF file instead, and perhaps we can use the gymnasium for that instead of pipe. And the gymnasium for that. All right, so let's get out of URDF and Pybble and let's move on to MuJoCo. This seems to have worked. MuJoCo and Pi. Robot XML, no. Robots, not an XML. URDF, robot, MJCF, when, Python, MuJoCo, m.py, please work. Oh. I got the following error. was looking for an MuJoCo file in the default assets diner. Yes, that's right. That's wrong. Okay, perfect. Perfect. Oh. Error range 0 should be smaller. Can you explain these error to me? Line 69. That's not even here. This error is coming from MuJoCo and just to parse your MJCF or converted your DF file. Specifically, it's complaining about the join. Here. 69. Here. The error range 0 should be smaller than range 1 in join. It means that the join limits are specified incorrectly. In MuJoCo, join limits are defined with lower bound, range 0, and an upper bound, range 1. So we have minus 80 to 80. Wait, but it seems fine. This is what I have for Revolution 1. Is it because it's in degrees instead of radians? Can be, right? Doesn't have any range limit specified. In MuJoCo, revolutions need to explicit range limit unless they're meant to be continuous rotations. If the join limits should be limited to specified ranges. Okay. Okay, so I suspect I'm gonna have to do the same thing. Can you do the same for the other joints where limited is not specified? Right, limited. It's a lot of them, man. Do we trust? Do we trust the AI to do this? Oh, actually, are they all in line? No. Unless it's a shoulder, yeah, in that case, shoulder from right, we already specified, right, I think, didn't we specify? Okay. I should probably open an issue in the on the K-scale library repo, because it should be able to handle this out of the box. Interesting. Oh, I see. Wait, render modes, render. Yeah, render mode human, there you go. What? Final and be close, try, simulation. Okay, well actually, okay, to be fair, I haven't read any of these, but I'm fully trusting the AI here. I should be reading this stuff. Expected value, actual value, 100. Okay, fine. Oh. please help me. Okay, here's the error, here's reset model. Okay, here's to fix it. Okay, that seems wrong, right? It's a little complicated for a reset, but this thing is just lagging. It doesn't even run. I think we already had some interface somewhere. Wasn't it this? No. MJCF to yeah, this. Okay. Right. So this, and then robots. URDF. Yeah, we already had some for this. Yeah, there we go. Yeah, always complicating things, man. Okay. Why is it flying? Well, you know, great question, excellent question. It's because I think it was like on a certain condition it was in collision with the ground. Why does it continue to fly? Well, perhaps there is no gravity. Let me check. It's definitely flying. I agree, it's flying. Gravity. I think the gravity is actually usually defined in the MJCF here. Gravity. Either gravity 009. Right? It is coming down. See? That was just some inertia. You guys have no patience. Boom. I mean, I don't know. I don't know what to say about the realism of the physics here. Like, it's a lot going on, but okay, the robot is in MuJoCo now. So the next step is to rebuild the 4-bar linkages that we had to destroy. And I'm gonna go to the bathroom real quick, but yeah, basically gonna tell the AI, gonna try to see if the AI can help us do that. So it should be straightforward, but just give me one sec. And I'm not gonna drink more Diet Coke. All right, I'm back. It's been like maybe like 1 minute. It's still moving. It still has not reached steady state, and it's moving in weird ways. Why? I'm not sure. I'm not sure. Actually, like, let's see if we have some random. We're taking some steps here. MuJoCo environment. We might be having some random sample. Yeah, we're taking we're putting some random inputs, I think, into the joints. That's why it's moving weird. Okay, so we need to identify which joints we broke on the MJCF. Also, some notes, I guess, here was that, oh, lagging. Some notes was that the K-scale on shape to URDF to MJCF doesn't handle joints with no min-max limits. Well, had to manually overwrite. Maybe create a repo issue for this. Right, so that's my only note, actually. Yeah. Okay, next, okay, which joints did we break, right? So for each leg we broke 2, right? Now all the joints, like all the parts have names. So here in our MJCF, we look for push rod upper, push rod upper. And there's a push rod upper. It's a lot of push rod uppers. Push rod upper, push rod. They all say 4. Push rod upper. They all say 4. But here, there's a 1, 2, 3, and 4. There's or a 2, 3, and 4. So there's a missing joint. Let's see what else we have here for push rod. That's just the body, right? So the push rod should be connected to this thing here, RHS servo. So I guess something that would help. I don't know if we can do these, but push rod upper. Rear right. Like if we change the name of this one, will it change the name of all of the other ones? Yes, it does. Okay. So that's not a good solution. Okay. So basically, yeah. Okay. What about this thing here? Basically, we need to make sure we're creating the right joint, but they all name the same thing. So, what about rear? No subassembly names. Okay. So how do we know which one is in which joint, in which file? I don't think we can tell. Push rod. Like this, like which? How do we distinguish between these guys? So how to distinguish between these guys, also these guys, and also these guys, right? So there's 3 parts that are the same in all legs, basically, kinda, that we need to distinguish. One way would be to create different parts for each of these and name them something different. Yeah. I'm kind of bored of these right now. I think I'm gonna go for lunch, proper lunch, and then I'll be back. We'll probably just rename them something different. I think that's okay. It's a little silly to like drive your cat's naming convention based on something like required for simulation. I think it's silly. But it might just be the cleanest way. Yeah. Anyways, I'll be back in a bit. Alright, I keep dragging my feet, not finishing this, just because it's so lame and boring. But I need to finish this, right? So, and just to be clear, what I think it's lame and boring is the fact that I can't go straight from Onshape to MuJoCo. I think that's pretty lame, right? Okay, so to recap, this is where we're at. We have these. We have our robot, almost complete in the MuJoCo environment. You can ignore the fact that the robot keeps flying away. That's not important. I know it seems important, it's not important. What's important here is the fact that the 4 linkages are broken. And so we need to rebuild these 4 linkages. 4 bar linkages. All right. And so we have this file. This is the MJCF file. This is basically what MuJoCo does is it reads this MJCF file and then it uses the meshes to define the outside geometry of the part. It's basically STLs, right? If we go here, STLs. So that's the mesh of each part, and then the MJCF file tells MuJoCo where each part goes and how it connects to other parts through joints and stuff. So now we need to modify this MJCF file so MuJoCo knows that the 4 bars are supposed to be linked together and how they're supposed to move. And then we ran into an issue recently where all the push rods have the same name, so we don't know which one is which. So how do we distinguish them? But I think we can figure it out. Like, yeah, we could split the parts and have different names, but so on my notes here, I'm gonna write in the MJCF file, it's hard to distinguish the push rods. It's not just the push rods actually. It's push rod that's the issue, right? So this part here, push rod upper, the push rod, the push rod upper, push rod knee, cam, and this part here, the servo cam, and the servo cam from each other, right? So they all look basically, if you look at the file, you search as push rod upper, and you see here which one's which. It's hard to tell, right? But I think we can distinguish them based on their starting position, right? So for example, push rod upper, this one starts at this position. So I'm gonna save this on the side here. I think we can kind of figure out which one's which, just based on the start position. And this is just a theory. I don't know this for a fact, but I think this would make sense to me, right? And if you're a reasonable person, this would make sense to you too. So if this doesn't make sense to you, ask yourself, am I a reasonable person? And the answer might surprise you. All right, so for example, these are the push rods we have. And there's a lot of fluff here, which we don't need. Oh my God. Okay, I'm gonna keep the fluff for now, whatever. Yeah, so I'm gonna ask the AI here. What are the coordinate axes for for position? So it's X, Y, Z, right? X, Y, Z, X, Y, Z. Yeah, okay. Pretty self-explanatory. So we have some files here. Actually, first of all, let's see what the X, Y, Z for on shape is. Right. So this is our file. X is left to right, right? So if the push rods are roughly aligned, which they seem to be, two of them should have the same X and two of them should have this roughly the same X, right? So these and these roughly the same X, and actually this and these also roughly the same X. Actually, they all have roughly the same X. So we're looking at the wrong line here. That's okay. That's okay. Let's just keep looking. can I tell the starting position in XYZ of push rod upper from looking at the MJCF file? So I think that's a good question. Yes. Push rod upper, you need to add all of the post values in the parent chain. Oh my god, that's okay. Well, okay, actually there's a parent chain, that's good. I actually do not see a parent chain. Body. So these are the assets, right? So this lists all the parts. This is the world body. So this would be the parent chain, I think. Root. Body. Left LHS front. I imagine. What do you think that is? LHS front. Actually, I don't know. Left hand side front, right? Left hand side front. This guy. So this guy contains a hip horn, LHS front, body name. Huh. This is an LHS front. Body name root. How many roots are there? RHS front. Interesting. So, but first, is there an extension to better visualize the MJCF? Maybe not, but no. Someone build that, please. Okay. This is the rear. See, this body finished here. Rear right servo pass, right? And there's this one here. RHS. Right hand side front. Okay. Okay, so that's another way to look at it, right? So I'm gonna write on my notes here to remember for next time. So hopefully next time this can go smoother. First of all, maybe we don't have to do this again. Next time, no 4-bar linkages, direct drive. You can sort of tell which push rod goes where based on its parent chain. Right, so for example, where's the first push rod? Push rod upper here in. Okay, so push rod upper equals LH left front, I think. So left front has LHA's front. Yeah, and then underneath here is push rod upper, right? I mean, does this sound crazy to you? And then push rod upper 2. So push rod upper 2. No, just no. Don't mess with my formatting. Google Sheets or Google Docs. Just don't do it. Right hand side front, right? So, and then push rod upper 3, and then push rod upper 4, right? So you can kind of tell. Obviously, I mean, I trust me. I realize rear right servo, rear right rear. I realize how bad this sounds. I'm sure, like left rear. I'm sure all the actual robotic engineers are thinking like, oh, this is very dumb, but this is kind of working. All right, so next we have the push rod cam, right? And push rod cam here belongs to. Okay, so it looks like we can. It's the same order as the other pushrod stuff, right? So pushrod 2. Yeah. Okay. Cool. Same order applies to pushrod cam files. All right. And then the only other unknown is are these guys here, right? So we have this guy, which is LHA's servo cam, which is, I think there's going to be 2 of them. So this guy and this guy. And then this guy will have a different name. It's going to be RHS servo cam. So there's going to be 2 of those. Not as bad as the others, just because there's less of them, but... And again, I understand how crazy this seems. I understand. Servo cam. This is in left rear. Oh. Oh. Okay. And then servo cam. Right front, and then this must be right rear, right? By this carcass, but let's triple check. Yeah, rear right. Okay, cool. So now that we know what goes where, the question is, how do things connect, right? So for example, this guy here, knee horn, right? We can go with knee horn. We know that the knee horn connects to the pushrod cam, but where is this specified? Body, okay, body name pushrod cam. So it's kind of like, so the pushrod cam is kind of like inside of the knee horn, and the joint name is here. And I guess this position identifies how they mate. Right? It's kind of weird. So one idea I have is to basically recreate these. So we're still gonna break the mates, but on one side we break them on one end, and then the other side we break them on one end. And so our final file has them, has both parts that we need. Right now we broke them all in the same spot, so it's kind of hard to tell. So that's one way of doing it, if that makes sense. I don't know if I'm making sense. It sounds like crazy talk what I'm saying right now, but okay. What's interesting is that the joint names did actually survive, so that's good. Yeah, so I think I'm gonna do that. I just want to save the AI prompt for this thing we did before. AI prompt. I'm just gonna save that. Whatever we used before. And trust me, I understand if this doesn't make perfect sense. I think this is very dumb. Um, this is not the exact prompt, but this is what I'm gonna save. All right. Okay, so my plan here is as follows, right? So for 2 legs, for the right legs, keep it as is. For the left legs, reconstruct the 4 bars linkage here, up here, and break it down here and down here. And then we mix the 2 configs, and so we can kind of tell how it's supposed to work, right? Again, I understand how weird that sounds. Or like, no, not weird, just literally silly. Just like, why is this happening? This is the state of robotics in 2024, guys. Rec 4 bar top 1, and then 4 bar top 2. I guess we can just do it for 1. All right, so that's good enough. And so now we can go here and we can run everything again. We can close resume. Don't need the same. And basically what we're gonna do is we're gonna run run these. We're gonna recreate the URDF, the MJCF, sorry. Okay, and so we're gonna attempt to open that MJCF. It's gonna give us an error. It's because it's missing joints here. It's like here in these. Oh, sorry. In these. Sorry, I'm gonna explain. I am getting the following error in my MJCF file because some continuously rotating joints are not specified with limited equals false attribute. Let's see if we'll figure it out. I'll help you fix should be continuous. Okay, it looks like it's gonna, yeah, it looks like it figured it out. Let's see if it should be pretty straightforward. I mean, this is the beauty of AI. Like for stuff like this, it works great. All right, now let's try to run it. Maybe it missed one spot, or maybe I missed one spot. I know it's resistance. Okay, it's possible that it missed some spots here. Alright, these worked great last time, so. Still working through it. There's a lot of them. Okay, let's try it now. Okay, so it renders. This is basically what we had before, right? Except now, I mean, it's exactly the same we had before, except I think, you know, the front left joint should have a slightly different. Oh my God. Yeah. All right. Anyways, whoop. So on the front right, no, on the rear left, we did these 4-bar top, right? So 4-bar, oh, 4, nope. Oh, that's interesting. That should be there. That's, why is that not there? Are we rendering this the correct thing? Let's check URDF robot. Yep, that's the one. I don't know why it didn't catch the name of the joint, but it should be here somewhere. Joint name Revolut 5, Revolut 4, Revolut 1, knee horn, push rod. Joint name DOF shoulder front right, Revolut 2, Revolut 5.2. There isn't a 5.2. There isn't a Revolut 5. So you just totally ignore the names, I guess. Front left, mates. Oh, it was here, in the back here. Okay. Yeah. LHS rear. LHS rear. Why didn't we catch the 4-bar? Maybe try it again. I mean, this kind of sucks, but nope. I also wonder how it picks the sensors, but it's like it's not catching the names for that one, which is, it's odd. I don't know. I'm gonna try something. I mean, is it because they are capped? Probably not. It's probably not that, but DOF seems to take them when it starts with DOF. I mean, this is kind of a bit, this is reaching. It's probably not that, but just trying things. Again, find it pretty annoying. DOF. Still nothing. Refresh. Annoying. Call run. about here? Not here either. I'm gonna nuke these. Start fresh. Will probably make no difference, to be honest, but gave an error. Missing join limits, that's why. So these joins were suppressed before. This was before, in a time when I didn't define limits. That was my bad. I guess that kind of makes sense. Okay. I'm gonna nuke these again. Try it. Actually, one more time. It's like the whole day was spent just trying to import these to MuJoCo, which is pretty funny. Okay. So now if we go in here, robot MJCF, we should have DOF 4-bar, and we do. And so now I'm gonna ask it to, can you please make sure that all of the joins with no limited attribute are set to limited equals false, such that they rotate continuously. Thank you. Smiley face. Okay, it seems to be doing it. It might miss it and miss a couple spots. It is a pretty large file. A lot of lines in there. Okay, apply these. It's gonna take a few seconds. Okay, and then we can try to load it, and they'll throw off any other errors. It missed a couple spots. You tell it you missed a spot, it fixes it. It'll fix it, right? Oh. I think we missed a few. Okay, almost there. Okay, now I apply that. A few seconds to patch this remaining stuff. I don't know. Okay, I guess there's quite a few there still going. Okay. Oh, still going. It's gonna. I was gonna say it's kind of slow, but it's way faster than if I was to do it. So no complaints here. I'm gonna grab another diet code. Okay, so now that should probably be it. Okay. All right. So we're back to where we were before. So that's good. So now at this point, I'm gonna make a copy of this just as a checkpoint here. And here, I'm gonna try to get the AI to help us close the 4 bars. So I'm gonna say DOF 4-bar. Can you describe what the DOF 4-bar top 2 joint connects? And then what about the Revolut 6 joint? all parts should have both a Revolut 6 and a DOF 4-bar top 2 joint. That is to say that the push rod cam should connect to the servo cam and the lower leg. Can you help me make this change? Let's see if we can do that. It's kind of like abstract. I'll help you if I... And let's see if we can do it for all the legs. I mean, it is quite a bit of changes. So we're gonna add these, and then we're just gonna render this environment. Made it look easy, actually. Let's see if it's correct. Remember to use the proper naming convention as to not repeat joint names. So it used Revolut 6 for all of them. Let's try that. I mean, I clicked apply, but oh, okay, it's working through it. Yeah, quite a few changes. I think it's still working through it. All right, let's take a look. This is just naming convention stuff. I think it's kind of failing at it. Is there a joint thing? Joint. I found it. Oh no. Both use the same joint. I think this might be it. Obviously, this is so annoying. This is not a good process. I just want to see if it's gonna work. This already makes you not want to ever build any robots ever again. It's just terrible. Oh my god. What is this error? Dude, no freaking way. Well, these are the same thing basically. Left front. Can I do it? Can I just do it manually? That's very annoying. Alright, let's use the checkpoint here. I mean, I'll write it manually. I don't care. This is just so stupid. Okay, just one of them. So this is all it takes. Let me try something else. Let's fix one single leg first. And if we can fix one single leg, then I'll have hope that we can fix an entire dog. Oh my god, dude. Please define all joints with no limits as joints with limited equals false, such that they can rotate continuously. And we already know it's probably gonna miss a couple. It didn't miss a couple. So smart. AI is taking over our jobs. Okay. So that's where we were before. Clearly the forward is not closed. Missing two joints, right? Cool. So we're missing these two joints here. So I'm gonna manually, like a savage, come in here. Obviously, do not recommend doing this. I'm a professional. That's the only reason I'm doing this. You should not do this at home. Okay, there's a few more instances. Motor names, I guess, because you know, something you need. Motor names here, because I guess joints are motors. Also, I mean, not really, but okay. We might have to delete those later. I still don't know what a motor means in the MJCF, but obviously you would think it's an actuator, right? And obviously we don't need that. Okay, and then two more instances. Honestly, not that bad. Which leg is this? LHS? No. RHS? Yes. Assets, world body, it's RHS. LHS servo cam. So under servo cam, I guess it's unclear whether a single body can have more than one joint, but I guess we're gonna find out. It's possible, I think. Well, we can ask CI. In MJCF, can a single body have more than one joint? Also, we can just also Google here how to model a 4-bar in MuJoCo. And it says no, in MJCF, a single body cannot have more than one joint. Each joint defines a connection between a body and its parent body, and since each body can only have one parent body, it can only have one joint. How would you then go about defining a 4-bar or any other loop or any other kinematic loop? In MuJoCo, kinematic loops are modeled using equality constraints. Yes. Break the kinematic loop at one point. Yes, done that. Model the mechanism as a tree structure. Kinda depends what you mean by that. Let's see. MuJoCo provides several types of equality constraints for this purpose. Connect fixes the relative position between 2 points on different bodies. Weld fixes both positions and orientations. That's not it. Joint constraints joint positions to maintain specific relationships. Constraints maintains a fixed distance between points. Okay, and then their example, we have ground, crank joint, rocker joint, and then an equality, connect split. Okay, connect body, rocker, anchor. In your example, can you break down how the equality constraint works? What is the anchor? The anchor is a point in the world coordinates where the body should be connected. Okay. Push rod upper to servo cam. Okay, so in my MJCF file, I'm trying to close a 4-bar loop by connecting. Let's see if we can figure it out. This sounds hard. Okay, equality, connect push route. Yes. Okay, that was like 3 lines of code. That's actually not bad. Okay, I guess I cannot fuck this up by adding these actuators. Which don't actually exist here, right? Yeah, they don't. And we now know we don't need these actuators. Same with here, these 4 bars here. Alright, so that was my bad. Fixed. Try again. And then we have a TOF 4 bar. I see. I referenced the wrong file. That's the issue. I mean, I should still remove all of this stuff here, which I add manually. Remove all of this stuff here. Remove. Apply. And it'll work, right? Magic. Let's see. Nope. I can't tell if it's incorrect or the anchor points are wrong, which of course you wouldn't know exactly what the anchor points are. I don't think you can calculate it just based on reading the file, but it's trying, so let's give it another try. I don't know. It's not great. Is there a way to precisely indicate the correct joint points coordinates in CAD so when I create my MJCF we can reference them? So how would I create that here? Test courses. I don't know if we would be able to see that, but let's try it. Yeah, not really. Right enough options here. Right enough ideas. MJCF. Visualize MJCF file. That last GitHub guy had the right idea. This guy. That's not a fun answer. How do equality constraints work in MJCF? The creatable and socket. Okay, in your file you're using connect constraint. This ball and socket joint. How many degrees of freedom does a connect constraint have? 3 translational degrees of freedom. Allows 3 rotational degrees of freedom. I only want to allow 2 rotational degrees of freedom as in a pin. Joint. I don't understand why you are citing Revolut 6 and Revolut 4 as joints. Can you explain? I mean, let's render it, see what happens. I don't understand, but yeah, we're flying through the sky. Seems wrong, right? I'm not sure which is Revolut 4 and Revolut 6. Let's see. Revolut 4 and Revolut 6. I see. And how come how is it able to reference joints like that? That's interesting. What is the best way to define a 4-bar mechanism in MuJoCo using equality constraints? You can use the well constraint and distance constraint to enforce the geometry motion. Would the joint constraint be any good? Okay, so we need a weld constraint and a distance constraint. If you want the hinge axis to stay aligned, use a weld constraint or additional distance constraints. You don't need that. Simulate and adjust. No. Body 1, body 2, anchor, so on. Kind of don't get it. Four-bar linkage, MuJoCo. Okay. So maybe we just delete the 4-bar mechanisms. Maybe this isn't worth the extra complexity. But if we do that, then okay, let's see. I am modeling a quadruped robot in MuJoCo. The elect mechanism involves a 4-bar linkage, but I am choosing to remove the 4-bar to minimize the kinematic complexity. Can I instead use inverse kinematic equations to translate the movement of the leg to the equivalent movement of the actuator? Something like that. Yes, you can replace the 4-bar linkage, translating actuator movement to leg movement. Model the SR trajectory, establish coordinate frames, derive, okay, done all of that, integrate into MuJoCo. Simulate the motion to ensure that, okay. Okay, but when training an RL model on these, how would I let the model know that it needs to account for the inverse kinematics equation? You know? I guess it doesn't matter. The model would just care about the leg position, and then I can just translate what the model defines as the leg position into the actuator stuff. I don't know why there's balloons. Right, so it doesn't matter. That'll be the easiest thing to do here. The only thing we need to account for are minimum and maximum rotations, which isn't hard. So maybe that's what we do instead. We just give up and we take the easy approach. And we can do that tomorrow. And then maybe I'll just post on Robotics asking for help, see if anyone has any ideas. But yeah, that's a plan. I'll do that.
Day 3.
Yo, we're doing this again. Oh my god, my camera froze. Every time, man. Why? Alright. Got a haircut. There was some miscommunication between me and my barber. There's a lot of product on my head right now, so we'll fix that. But also got new sweatpants. You can't see it. It's okay. Been thinking about this MuJoCo thing a lot. This 4-bar linkage a lot. Last night I went for a walk. To me it's like I'm in complete disbelief that it's so hard to model such a simple geometry in 2024, right? And just the thought of like that there's people that design their robots around what's easier to simulate, and like will base their mechanical design on what's easier for software to process. That is just fundamentally wrong with me. Like, it just rubs me the wrong way. This is not how engineering works, right? It's like, it's 2024. If it was, I understand that for the F117, this guy was designed in like 1983. I understand for that for this guy, the shape was based on like what we could, simulate on computers at the time, right? We were limited on the polygons, so we needed a simple shape to simulate for radar, for the stealth technology, right? That's why this aircraft looks like that. But it's 2024, right? Our aircrafts now look like these. Actually, I don't think that's a good example, but we can do curves now, right? And stealth curves. Like, I don't want my mechanical engineering to be limited by computers. That's so lame. But anyways, I was evaluating the options. It was like, basically redesign the entire thing, which is like what some people suggested. Uh, model the thing without the 4 bars. It's like, which is honestly what I was leaning towards. Probably the easiest. But before we do that, I thought it would be good to. I mean, technically, there is a way to get a 4 bar in MuJoCo. So why don't I just do that? Just the simplest possible geometry, right? And actually, a friend sent me a file. I have it here. I have an XML file here. But then he also mentioned a few things in MuJoCo about the docs that I had no clue what he was talking about. So I think I must spend some time today reading these docs. And the other thing I did, I asked Reddit. I love asking Reddit. Robotics is kind of like the only relevant subreddit. And I said, like, you know, I'm working on this quadruped robot. I've done the on-shape to URDF. I figure out that, you know, there's an issue with the 4-bar linkages or any other closed kinematic chains for that matter. How should I handle these? I haven't read the replies, but we got 4 comments. So this guy says, URDF doesn't support closed loops in the kinematic graph. MuJoCo does. See the. Oh, okay. Okay, cool. So there's a 4-bar example in the official MuJoCo repo. So that's good. We'll take a look. I guess I also said my other idea is simply not to model the 4-bar, which is what I just said. But rip. People talking about gazebo. Cringe. The second on-shape converter. Apparently, this guy has a repo for on-shape straight to MJCF. We could try this. MSIP write everything you need to build on-shape to MJCF pipeline. This package contains 2 base areas of functionality which function fairly independently. Data structures, utilities, and builder for MJCF. Okay. Abstract representation of both the raw CAD model and the inferred. Yes, obviously. Infer state topology. Yes. To get started, you can use it. Okay. Your MG will build this. Alright, so we'll try that and we'll try these. But before we do either of that, and I guess we still have these running for no particular reason. Oh. I don't know where the leg went. I don't see it. Oh. Controls are not great. Man, I complain a lot for sure. But having high standards is good, right? Having expectations is good. Maybe I don't get to have expectations. Alright, this is the basic MuJoCo stuff under programming. Simulation. Oh. Wait. Yeah, so there's like a very simple way here. The pre-built distribution. Yeah. Okay. I guess what I'm getting into here is like what I have been calling MuJoCo so far might not be MuJoCo. Like it's the MuJoCo M from the gymnasium library, but this is what the MuJoCo sim actually looks like. Like, I guess like this. And I only figured this out because a friend was showing me his MuJoCo and I was like, oh wait, that doesn't look like anything like what I have. So I've been using Gymnasium all this time, and I guess Gymnasium has a MuJoCo powered version or something. So I'm gonna put this in the in our fun docs thing here. Eventually read these to get actually good at MuJoCo. So I'm gonna ignore it for now, of course. Yeah. Anyways, this is the 4-bar example that my friend sent me, and I think it might just be the same. Oh no, it's not. Let's try to find the link that Reddit person provided. And I realized I've closed a bunch of things now. Okay, so this is interesting, and I guess this guy linked a GitHub issue 172 with an example here. How can I get some example to simulate a closed-loop mechanism for row linkage? For MuJoCo, as far as I know, there is no native support. That's wrong. Indeed, 4-bar should be implemented using equality. We hope to have some example code soon. Okay, there's an example video here. You can see their MuJoCo stuff. Oh, this is probably not screen recording correctly. Their MuJoCo stuff looks different, but it won't play. Let's see if I can watch the whole thing. The video is broken or something. Anyways, why don't we try this? 4-bar, 4-bar example. Alright, so 4-bar example. That's no. Robot XML. Alright, so there we go. That's the 4-bar example, and there's the example Python to run the sim. Sim file. You see we are missing some dependencies here. I'm gonna attempt to do pip install MuJoCo viewer. I'm gonna instead ignore that. I'm gonna run these, and I mean, it's obviously not gonna run, right? So, and then we can ask the AI to help. Some modules are hard to install. Oh. Interesting. That seems to have satisfied. Oh wow. Okay. Alright, so this is not Gymnasium anymore, different viewer. But that is indeed a 4-bar. Now, of course, the question is, how do I get this to move? Trying to figure out if there's a way to insert a force here. Graph viewer. Alright, feels like progress. Just not sure. Sure, like I got that far. Maybe I can help. Is there a way to exert a force by clicking with my mouse? Why do we need NumPy for that? Wow. Sorry, where are we using NumPy? We're not using NumPy. Yeah, why would we import NumPy though? No import nonsense, man. Python. It seems like the MuJoCo viewer API has changed. Well, let's find the docs. Render context, not a thing. MJR render viewer, MuJoCo viewer, MJ model, MJ data. What changes you're proposing? Cam flex, are you sure? You sure? Cam, oh, bro, I don't know. So you do it. Is MuJoCo and MuJoCo viewer different things? Dumb question, but interactive viewer, MuJoCo viewer. Yes. Clicking. I mean, I'm gonna let the AI try to figure it out, but MuJoCo viewer apply force with mouse. Code examples, test speed. Give model, simulate control dynamics based on passive. Simulate, compile, record, drag. By holding control and dragging the mouse. Let's try that. I don't know why it opens up and takes the entire screen. I realize you guys can't see. The user can apply a force by holding control and dragging the mouse. These are fake news. This is not true. The user cannot do such thing. Oh, yes, the user can do it. The user has figured out how to do it. The user is confused as to what's happening now, but the hell? The user did a thing, but it's like a force vector or something. The hell? Anyways, that is a forward indeed. The user can confirm that we're forwarding. Of course, now this element here is static, right? So we have 1, 2, 3, 4 static, but that is indeed a 4-bar in MuJoCo. So this is possible, right? It's just a skill issue. So if we go through the XML, which as far as I can tell is the same as an MJCF. There are 4 assets, color-coded assets, right? So the 4 assets, and there's the word body, there's the tree, right? So first we have link number 4, name link 4, join type hinge. Actually, okay, type geom, type plain, link 1, link 2, link 3. Interesting. I thought the asset names would match, but okay. Oh, I guess this is the materials. Okay. Okay. Joint hinge. An axis. Position 0, 0, 0. Axis 1, 0, 0. Not sure what. It's not SCI here. What does axis 1, 0, 0 mean? Oh, I see. 1, 0, 0 means rotation axis points along the positive x-axis. So they all should be axis 0, 1, 0, 0, and they all are. And what's special here is we have an equality, connect, kinematic link, active true, body, link 1, link 4. Body 1 equals link 1. And then body 2 equals link 4. Anchor 004. What does anchor 004 mean? Right? Obviously something on this Z axis. 4 units up. In your 4-bar linkage, these connection points is at the top of the first link. Okay. Now, I think what would be interesting is what happens when we delete these, right? And then we rerun our sim. I think the top bar, the white link is not connected anymore, right? So they look connected because that's where they started, but there's no joint defined, right? So yeah, there you go. Well, apparently press escape escapes the simulation. Counterintuitive. Makes sense. Okay. Oh, this red guy is rigid, no matter what. Alright. Oh, no clashing. Alright, interesting. Why is the red element link 1 rigid? Huh. Let's try that. So now all the links should be rigid. Sorry, it should be movable. In MuJoCo, links by default are rigid. Okay, indeed, it moves now. How can everything move? Wouldn't the whole thing just collapse? I guess not. I guess this... Huh. That's interesting. Okay. Well, I don't know if I'm learning anything here. Like, I'm learning 4-bar is possible. You just gotta like destroy your brain thinking about it. That was my takeaway here. Okay. So 4-bar is possible. It's just kind of, you kind of like just have to like think hard about it, I guess. Or my brain is too smooth for this stuff. That was interesting. Okay. What about this guy on shape to MJCF? Cinematic tree. I mean, I'm down to try this. Doesn't say how to install. I guess this is the biggest thing for us. Build your kinematic tree by graph analysis of your CAD document. You must provide a root. Joint made ordering doesn't matter. You must provide a root. What is a root? What's a root? Okay. Guy forgot to. Huh. I mean, I imagine he wants us to download this repo, right? I'm not gonna clone it. Download your repo. Can you tell how much interest I'm losing in all of this stuff? Why is this part so complicated? Such a simple thing. On shape. MJCF master. Alright, perfect. How do I install this? Should I open an issue? How do I install this? To get started quickly, you can use the onshape basic command provided. Yes, but how? How do I install this? Name. Oh, okay, I see. Maybe I missed something. Onshape MJCF. Bro, I don't wanna. So I'm running the wrong version of Python. Oh my god, dude, why? I'm back to nothing works. Yes, Here's a fix, update the Python version requirement in PyProject. Oh, that is a fix for sure. I mean, what if there's a reason for this requirement? But no one is gonna know, right? That's funny. There's probably no reason for that requirement. Oh no. Alright, it seems to kind of run. Guys, you know what? This is ridiculous. I'm not interested in this anymore. I'm rage quitting. Rage quit. Rage quit. My version of rage quit is moving all these to the archive. Archive. My robot. My robot was fine. No, we're not using my robot. We're gonna use the K-scale stuff. Okay. This is me rage quitting right now. Instructions. All right, rage quit. I'm done. This is like very dumb. Why is this so complicated? It's literally a 4-bar. CPD has 1. It's okay. All right. I mean, like, I'm sure I can figure this out. It just doesn't seem. It seems very silly to spend so much time on these. Like, honestly. But at least we proved that there is a way of doing this. But now we are rage quitting, which means I'm gonna do the other way of doing this, which is, let me show you the silliest way of this is like, you should be ashamed, basically. As far as I can tell, this is how the Stanford Pupper did it, right? Basically suppress everything, don't need it. This is what you actually need, right? And so you can do call run these, unless I missed something. A little laggy. I'm gonna get for a little bit more coffee. Yeah, so I was saying I refuse to like change my mechanical design for whatever, just to like work with the simulation tools, the software tools, but turns out I want to do just that. I lost the battle. I tried and I lost. Now we're getting some new issues here. Looks like we have a new compatibility issue, and that might just be because I installed a bunch of things from that random GitHub repo. Fun. I mean, you should have a virtual environment for these things, right? I know that much. Okay, that works. NGCF. Rename these to okay. So that's our leg now. And yeah, you could say, oh, you're missing some elements, so the kinematics are not the same. Sure. The kinematics are not the same. The inertias are not the same. I get it. They will be close enough. My only concern is setting proper joint limits for the leg lower. Now that we don't have the rest of the 4-bar to check for inner clashes, like the linkages clashing with each other. So we gotta be a little more careful. Fortunately, it's fairly straightforward to set up limits, but basically we gotta measure here and we gotta measure, I don't know, like what was the other limit here, and this angle there, and then this angle there. And I do feel silly doing all of these. Just for the record, if you're watching these and you're like, what? I understand. I get it. Just trust me. Like I know I'm cutting corners. All right. I'm just trying to get to the point where we can actually get something to walk. And then we'll do things better. We'll learn. We'll iterate. We'll improve. We'll evolve. We'll conquer. Like I always say, I always assume I know nothing and I'm doing something wrong, and there's a better way of doing everything I'm doing because I'm a noob. But I'm a noob who gets things done. That's the difference. That's the only difference. Interesting. So I'm basically assuming that the joint angle is independent of this thing here, because by the time we're clashing with this is clashing with this is probably going to be clashing here. Not really, but why would we ever go to this position, right? I feel like it's not going to be an issue. So the real angle we want to measure is from right, if this is 0, if that is 0, if this is 0, right, that's 0. Whoop. How is that 0? But that's 0. If that is 0, bro. Bro. Why don't we just eye it out? Just like, you know, something, just I feel like morale is already pretty low, so. Bro, you don't want that to be 0. Yeah, sure. No, bro, come on. Of course. This is just yet another reason not to use 4 bars in anything you do ever. There's a lot of reasons actually. See, I'm mad at MuJoCo, but actually, I should just be mad at myself. Why did you? I mean, you decided to use 4 bars. It's kind of like on you, you know. Everyone told you it's a bad idea, and you still did it. Okay, I'm happy with this range of motion. We're gonna call it that. 70 to 180. Yeah. We're gonna go to the bathroom real quick. BRB. All right. So we have one leg done here. I guess let me put this in sim. Just make sure our limits are showing up correctly, which I'm pretty sure they will be, but okay, they're not. Are they? Can't tell. Definitely not. All right. Oh, I know what's wrong. Basically, this file path is incorrect. I don't even know what this. Oh, I see. It's the old robot. All right, let's try that again. I feel like it's usually pretty good about respecting limits. Okay, that's definitely. All right, limits are not being respected. the name of this joint? DOFNE. Let's see. DOFNE. Range 0 to 623. Actuator range. Huh. I don't know if it's because I set the name to continuous. To clean that up. I think that's the reason. Let's try that again. Yeah. Bro, get out of here. I really feel like going skiing. Maybe this weekend. Oh no! That's so bad. Dude, stop moving. Yeah, it should be possible. Anyways, let's look at the actual file here. Daphne. Dude, it's not continuous. Why are you saying continuous? Why are you saying continuous? Let me just nuke these. Always works. I just want to say that if I actually manage to train an ML model to make this dog walk, I still think that's like a mind-blowing achievement. And yeah, you can look back at these videos and be like, dude, you barely managed to do it. And you would be right. I barely managed to do it. But if it works, oh, it's just wild. Oh yeah. That potential looks correct. Yeah, that's it. Other way? Yeah, it looks correct to me. Yes, nice. Yep. All right, cool. So now we just need to patch all of the other legs. Let's so it's a 3-step process, right? So it's like change the mate name, set these limits, suppress other components. 70 to 180. Oh, I just realized these the mate name doesn't apply to these. That's from a different library, pretty sure. All right, so that's okay, and then we can whoop, go to assembly. Okay. Okie dokie. 70 to 180. 70 to 180. Play it. Yo, chill now. That looks about right to me. That's definitely wrong. That's definitely wrong. That's wrong. Looks about right. Is it supposed to come up this high? Whoa. Let's try it. Different like. Can you? Oh no. Not even close. So it's the other way, right? So 20. No. it's mirrored, right? So we gotta rotate some shapes in our heads. 180 minus 250, something like this. I mean, isn't that the same thing? What does this look like when I cycle it? Okay, what does this look like? Let's see, 180. Too much. Not enough. I mean, this feels like the correct no, this feels like the correct orientation, but 70 to 180. Where are we measuring 70 from? This is just so random. What the hell? What about here? Why don't we ask ChatGPT 01 mini if I have a crank that revolutes from 70 degrees to 180 degrees and then I mirror it, what is its angle? I understand it's a bad question. I didn't give all the inputs. I'm just curious how it's gonna think about it. Yeah, I thought about it too, right? 0 to 110. Oh, I didn't try 0 to, like, I'm just gonna admit the L here. I didn't try 1 to 0. Yeah, that looks correct. Yeah, for sure. ChatGPT 01 mini saved the day. AI is taking our jobs. It's taking my job before everyone else's. AI just took my job. It is absolutely so over. Okay, and then we have the top assembly here. Oof, that's a rough, mate. Can you please behave? Oh, actually, that is not the assembly we care for. This is the assembly we care for. Yeah, right. Oh, behave. Okay. Okay, so now this is, I think, closer to what we actually want to train. I was also asking ChatGPT because I've been pushing myself at the gym a little harder. I'm super tired. And I was like, why am I so tired? And ChatGPT basically says, oh, you need to drink more water. And the funny thing is, I think it's correct. I need to open an issue on the K-Scale repo because still doesn't do a good job at defining continuous joints, which we still have a couple in there. But I know those guys have a ton on their plate, so I don't know if they're gonna get to it anytime soon. I think they're short on software engineers. Stop flying. Okay. Wait, didn't I code something so like my mouse would put in a force? I thought I did. Or was that on PyBullet? It's possible it was PyBullet. Why don't we try this in MuJoCo itself actually? Where did I put it? Archive, and then for our example, SymPy. Let's see if this works. SymPy. Okay, these we don't have robot Excel, but we have even better. We have URDF robot MJCF. Maybe that works. Python SymPy. It actually looks the same. Can you please not fly away? Dude. Yeah, I can put a force like this. I'm in control. Not really, but alright. Okay, so that's it. We have the thing in sim. This is why does that not look correct to me? Dude, rotate. This click doesn't, oh no, it's correct. Okay, so I guess the next step is kind of like, how do we get it to stand and stuff like that? And that's an interesting question. It looks so sad. Yeah, that one's interesting. I actually don't have the answer for that one, but now we have the robot in sim, which is it took a long time, and we've got some corners, and a robot doesn't look the same anymore. But if you ignore the fact that yes, the legs look different, everything is happy, and we're getting closer. Now, in terms of how to get it to do stuff, how to animate it, I actually have no clue. So my first step was going to go back to the gymnasium stuff and look at their environments, their MuJoCo environments. They have the ant, they have the walker. They don't have a, I don't think there's a quadruped here. But I do remember there was a tutorial, training agents, gymnasium basics, load custom quadruped environments. This could be interesting to play with. Taking the environment simulation parameters. I think I can basically just copy these. Oh god. You can follow this guide to create most quadruped environments. Okay. Okay, that's very scary, but okay. So I think that's what we do next. So I'm just gonna add this to our document. I have no sense of how long this video has been going on for. Cool things to do. Done, rerun, done. Now we can say this is done. Replicating this document here. Hardware updates, new horns, shoulder horns, upgrade servos to 7B, move waves, potentially install IMU. How about we just remove the linkages in real life as well? The thing is, like, redesigning the robot is like, two things. First of all, if I was to redesign a robot, I probably wouldn't do quadruped right now. It's easier to start with something with less actuators. And then the other thing is, like, if I was to redesign stuff, honestly, I would also get different actuators. The servos I got were expensive. They only have mounts on one side, so it's not great for joints. And they're PWM, and I've now experienced how nice some of the smarter, kind of like, what do they call it? Like the serial bus servos are. So that's very exciting. So I'm like, oh, probably should change a bunch of things. Let's see if there's any open issues on the K-scale thing here. Issues on shape. Oh, this is Ben. Ben is the founder. Limits are wrong. I guess that's what he means. Limits are 0, 0, and in on-shape they are normal. What does normal mean? Alright, maybe let's create a ticket here. Robots, MJCF. I feel bad because he's basically saying like, oh, here, you fix it, instead of fixing it. Where's the thing here? Limited false, limited false. I'm gonna ignore it for now. Don't need this, don't need this. This was great. Alright. So vertical to the top. Let's just run through these, I guess. And actually, let's see what else do they have for quadrupeds, if anything. And I guess the ant is a quadruped. It is actually ant tutorial custom quadruped. There's a half cheetah. Oh yeah, that's interesting. Yeah, that is interesting. Okay, get your MJCF or URDF file for your robot. Create your own model. See guide. Oh, there's a guide for it. Dude, guys, too late. Oh, it's broken. I was gonna say too late. We just spent 2 days doing this. Find a ready-made model in this tutorial. We'll use the model from MuJoCo here. Okay. I'm gonna follow the example to the T, right? So on shape, MuJoCo quadruped example. Screen folder. Quadruped example. sample link. I'm gonna upload these so you can see it as well, I guess. Oof, a lot of changes here. A lot of files though. It's like slay. It's commit, slay, slay. I know some people write like good commit messages. That's not gonna be me. MuJoCo Menagerie. That sounds French. Oh wow. Oh, actually, MuJoCo Casey. Casey MuJoCo scene. What's that? Wow, some people have built some really cool stuff, man. Meet Casey. Yeah. Okay. Is Casey here? No. Okay. Find a ready-made model. Load the model. In this tutorial, we'll use the model from. Okay. Setup. Pip install gymnasium. Okay. I guess. All right. I'm pretty sure we have that already, but oh wow, it's still committing. CD quadruped sample. Obviously, we meet requirements. Unitary Go 1. From the excellent MuJoCo. I don't know if I want the entire collection made, but so can we? Oh no, I don't want to git clone in my public repo. Where's Go 1? Yeah, we'll just. I guess you can't just. I guess I have to download the entire thing. But I'm not gonna clone the repo, I'm gonna download it. Like I'll put it here and then I'll delete what we don't need. And that might take a while. It's big. I went to a hackathon on the weekend and it's like, we spent like one entire day, or I knew someone who spent like an entire day just downloading Isaac. I'm sure like why didn't, skill issue not to have Isaac installed already, but example link MD. OBRB while it downloads. I don't know why it takes so long. Alright, so I don't understand how, but basically I was downloading the file and I literally ran out of disk space. I don't know how that's possible. I literally had like 50 gigs free, so I must have installed a bunch of random stuff. Or these videos are getting too long. Tomorrow's the last day of recording of this series. Yeah, I basically just need these. And I know this is a super noob question, but can I download a single folder from a Git repo? Okay, well, kind of silly to be honest, but do I just buy a hard drive? Do I just buy a new Mac? T7? 4 terabytes. Probably don't need that much. It says it's on sale. Do I believe it? I do not believe it. It's indeed not on sale. It's been cheaper. It's been more expensive. I don't remember. T9. I think T9 is what you want, not T7. It's just faster. T9. 134, I think. Yes. All right, we'll get that. In the meantime, I don't want to feel myself like working through these issues because it's very simple stuff. Let's say a tutorial. Load the model, gymnasium import. Oh, interesting. It's just an P5. Although this is enough to load the model, we'll need to tweak the environment parameters to get the desired behavior from environment. What if I Google this? Maybe someone has already. Maybe there's like a separate download. Yes. Oh, parkour. Oh, that's so funny. How big is this thing? Does it tell you? Do people just have like huge hard drives? Oh wait, can you? Yeah, you can download specific files, can't you? That's gonna be so painful, but you can do it. Since, like, it's not the worst thing. And I definitely have enough space for that. A bunch of STLs and XMLs. Let's do it. Scrappiness, maximum scrappiness. Okay. License, don't need that. This XML, do need that. Boom. And then the environment, scene, yes. Alright, should be enough. And then we can continue. Quite a bit example. Pi. Okay, so let's try this. This will be the wrong model, I'm pretty sure. MuJoCo. My bad. MuJoCo. I'm sorry. Is there some MuJoCo assets scene? Why is it going on there? I mean, I'll put it there if you want, so that's where you want it. It's like, Oh, I think I see the issue. Okay. Nothing opened. Let's render these for humans. It's because it's not rendering for humans. Oh. Alright, let's see it. I'm pretty sure this is, I don't know, is this, okay. Okay. I mean, who did it better, us or them? What's in scene XML? Go one. Oh yeah. Interesting. Interesting that scene XML. So what do we have here? What does this file define when opening it in MuJoCo? So it defines the model for sure. Diffuse ambient, okay. So visuals, assets, skybox, checker, the ground plane, assets. Okay. All right. Okay. All right. Although this is enough to load the model, we'll need to tweak the environment parameters to get the desired behavior of our environment. For now, we will also explicitly set the simulation, termination, reward, observation arguments, which we'll tweak after. It totally skips on a render mode, so delete these. Render mode, I guess it doesn't care, but it's because it might have been written in a older version of Gymnasium. Render mode is the default human. Tweaking the environment parameters. Tweaking the environment parameters is essential to get the desired behavior for learning. In the following subsections, the reader is encouraged to. Alright, so they give us some homework here. I'm gonna close all these tabs. Arguments. I mean, there are a lot of arguments to read. I agree. To understand. To understand environment arguments, read these. Bam. For later. AKA probably never. Tweaking the environment simulation parameters. The argument of interest are frame skip, reset noise. Frame skip. Is there a frame skip here? Yes, one. Maybe I should read the thing. Frame skip. Okay. Frame skip, reset noise scale, and max episode steps. We want to tweak the frame skip parameters to get a delta t to an acceptable value. Typical values are dt between 0.01 and 0.1. Delta t equals frame skip times model opt time step, where model opt time step is the integrator time step selected. The Go1 model or that we're using has an integrator time step of 0.002, so by selecting the frame skip 25, we can set the value of dt to 0.05, which is just like 25 times 0.02. The Go model, where is this defined though? 0.002. No, that's not it. In this scene. I don't know where is this defined. But okay. To avoid overfitting the policy, reset noise scale should be set to a value appropriate to the size of the robot. We want the value to be as large as possible without the initial distribution of states being invalid. we want to be the, okay, we want the value to be as large as possible without the initial distribution of states being invalid. Termination, regardless of control actions. For go one, we choose a value of 0.1. And max is 7 the number of steps per episode. Truncation, before truncation. Here we set it to 1000 episodes before truncation. Truncation to be consistent with the base gymnasium MuJoCo environments. But if you need something higher, you can set it so. And so they give us some stuff here. Max episodes 1000, frame skip 25. So I guess, oh, and actually they changed more things. Oh no, they didn't. So what changed? The reset noise scale from 0 to 0.1. Frame skips from 1 to 25. Max episodes stays 1000. Tweaking the environment termination parameters. Termination is important for robot environments to avoid sampling useless time steps. The arguments of interest are terminated when unhealthy and healthy set range. We want to set healthy set range to terminate the environment when the robot falls over or jumps really high. Here we have to choose a value that is logical for the height of the robot. For go one, we choose, okay, that makes sense. That is actually a pretty wide range. I don't know how tall this robot is, but healthy's set range checks the absolute value of the height of the robot. So if your scene contains different levels of elevation, it should be set to, oh, I see. If your scene contains different levels of elevation, yeah. That'll be tough to train, but that's not even gonna think about that right now. We could also terminate when unhealthy equals false to disable termination altogether, which is not desirable in the case of go one. Gonna copy these. Okay, so what changed here, right? Like basically only the healthy set range changed, which was 0 and infinite before. Now it's a height adequate for the robot. If you need different termination conditions, you can write your own. Tweaking the environment reward. Interesting. The arguments, I should just put this link here. Following this. The argument of interest are forward reward weight, control cost weight, right? So for reward, a reward for moving forward, control cost, right? A reward for, or a cost for moving, right? That's common. Contact cost, so we're touching the ground, I guess. Health reward for when we're in a position that didn't kill us, aka we didn't crash to the ground. And main body, not sure what main body means. We have to pick values that make sense for a robot. You can use the default MuJoCo ant parameters for reference and tweak it. In the case of Go 1, we only change the control cost weight since it has a higher actuator force range. For the argument main body, we have to choose which body parts is the main body, usually called something like torso or trunk. I see. So we need to choose what's the main body, because that's what's used to calculate the forward reward function. Bunch of things change here. Basically all the weights used to be 0 or close to 0. Observation parameters include looks like we're not changing anything here. It's just the default and stuff. No definition, such as additional sensors, you can write your own. Train your agent. I like how it says just, oh yeah, just train your agent now. That's funny. This is where we can use SB3, I think. I feel like that was the hardest part, but okay. Finally, we're done. We can use the R algorithm to train an agent. Note, if you have the following guide with your own robot model, you may discover that during training that some environment parameters were not as desired. Feel free to avoid. Okay. SB3. Oh yeah, there you go. SB3. MuJoCo would go on for runs. Okay. It's an SAC algo, and episodic return. So this is a reward, I think. And this is per episodes. Train to 1 million episodes. I'm gonna go to the bathroom and I'll be back, and we can implement something on SB3, and I guess we will train overnight and kind of like take a look tomorrow. I'll be right back. This is a good part. All right, let's train this. Let's train this thing. Let's attempt to train this thing. I guess we don't need anything below this here. All right, so last time we did bipedal SB3. Our latest pipeline was experiment 3. So same thing here. So we're gonna have train and evaluate, right? So before we had bipedal SB3, and well, let me just copy the entire code, because that's basically, I think we're basically using the entire thing. We don't need AI right now. Okay, so Gymnasium NumPy, SMP, don't need that. These are algorithm specific, I think, not environment specific. Okay, another thing we could try, sorry, I know, what we could try is, I want to train the environment I have defined in train.py using the SB3 pipeline in bipedal SB3 experiment 3 and bipedal SB3 pi. Can you help me bring the required components from bipedal SB3 pi into train.py? Similarly, I want to be able to choose models and specify time steps. Okay. Let's try this. Yeah. Oh. I guess you want PPO by default. Okay. Sure. Evaluate by pedal. Evaluate here. can you help me modify so that it uses the same environment as train.py? Remove custom observation wrapper. Why did we have custom observation wrapper? Oh yeah, because we modify the observation space. We don't need that. It should be. Yeah, we don't need that. We need that. Yeah, okay. This is already training. How do I open tensor port for train? Opening tensor port here. No. So this is PPO first of all. I'm not saying it's correct. Eval, rollout, don't care about rollout, care about eval. Alright, so we're saving every 10K, right? So we could evaluate right now just to take a look. And I think it's important to mention that our reward, we have a forward reward, right? And I think they just borrow these from the existing gymnasium, the end environment, which has a reward of a reward for moving forward. If the end, yeah, right. So that's so basically. When we evaluate these, it's gonna try to be moving forward. Just put it out there. Pi algo PPO checkpoint, I think it's called. Was it checkpoint? Yeah, checkpoint, and then we just choose the checkpoint. Obviously it keeps going. It actually looks very nice. Checkpoint. Okay, let's see. Oh, it's on its head right now. Okay, well, I mean, I said it looks very nice on paper. Obviously looks awful, you know. But just keep in mind, look at the curve here, right? Like the rewards here get to like 3,000, 4,000. Our reward right now, it's like 30. And I guess the other thing I was curious about is why was this ant thing able to just take the Go 1 model so quick? You know, or we define our environment here. I guess it's because ant b5 was already a quadruped, and really all we did was change the model. Just change the model, which is fine because it's I guess it's fine because all quadrupeds are the same anyways, question mark. Right, they have calf, hips. Yeah, I guess what I'm going is like, I wonder if we could just as easily replace the Go 1 or the ant with our own model, right? But anyways, we're also going to kick off this same thing for SAC, PPO and SAC. SAC makes more sense, supposedly, I guess. I speak like I knew, and I say that as if I knew what I'm talking about, but you know, at this point we've run some experiments. Train pi, I'll go. Oh, you know what's the other thing? I didn't specify how many time steps. Default is a million. Algorithm here is SAC time steps 100 million. So not that it matters, right? Because PPO, we could kill it, to be honest, but yeah, we have another training run here. This one's more relevant than anything we've trained before. So I think this will go probably well, and after we can kind of figure out how to train on our geometry, which shouldn't be hard. We just need the XML file for Go1. We already have the XML file. This is just the MJCF. It honestly might just be a question of like, you know, where are the actuators, where are the sensors, and so on. And what's in the observation space. We should understand the observation space. But other than that, it's honestly probably pretty good. So wait, where's the SEC? It's taking so long to oh yeah, almost getting at 10,000. Anyways, we'll restart this tomorrow with some results to show for. It'll be interesting to see if like training 3D is as easy as training 2D, right? Anyways, see you tomorrow. Or later, or whenever something interesting happens. I'll come back. And I'll in the meantime, I'll go find some hard drives, I guess. Like.
Day 4.
Hello. I mean, kind of like putting this off. Kind of like didn't want to make another video. This video has been dragging along for too long. I kind of like just want to flip the page. There's also a whole thing of like, I feel like I spend so much time just trying to figure out how to export an unshaped file, and I felt very not smart. So I'm like kind of like just want to be done with it. But anyways, let me show you. So so I left one of the SB3 training runs running overnight. I also ordered a new hard drive because my computer keeps running out of hard drive. I currently had 63 gigs, so I did clear a bunch. What I found out was that actually, let me show you here, but the training runs actually take a lot of space, right? So on training runs, we create a logs and a model file. That's what TensorBoard reads from, the logs file. So the logs file is pretty small, 3.2 megabytes, right? But the model file, right? Every time we create a model, these are the checkpoints that we can then run again. These are like 2 gigs each. And so before, we were saving these every 10,000 time steps. Where is it? Here. We were saving every 10,000 time steps. We were doing an eval callback and checkpoint callback. I changed it to every 1 million. So now we save way fewer. And what else? I guess what's important here is that if we look at the results from the tutorial we're following, and I think that's what this chart means. It's not entirely clear to me, but I think this is their reward, their mean reward curve. And you can see here at about, what is that? Is 1 E7 10 or 1? I can't tell if it's 1 million or 10 million episodes. 10 million episodes. 10 million episodes, yeah. So I don't know how long it took for them to train this. I think these are time steps on my x-axis, not episodes, and I'm at 10 million here. It's still running actually, but since we only save every 1 million, you know. Oh, actually, I guess that was it. I ran it for 10 million. So this is what I got, right? This is what it looks like. The mean reward is over 4,000, which is very similar to what these guys had, right? So seems to be good, very nice. Basically recreate the same chart, I think. And of course, then the obvious question is, okay, let's evaluate what does it look like, and I'll show you just that. The answer is not great, but so we look to the 10 millionth checkpoint. This is what it looks like. Now the thing is moving very fast, so actually it went out of frame, and you can try to chase it if you want to play that game. But you can also, here it says switch camera, switch tap. Camera 0 tracks the object by default, at least that's how it's defined on the AND environment. Camera ID 0 tracks the object. And so you can see there's two cameras. I'm on camera ID -1. Click tap to switch camera. There's the other camera. So this is the guy. This is how it's moving. Now we're kind of zoomed in, so very zoomed in. So it's perhaps hard to tell which way it's moving. Actually, can I zoom out the camera ID equals 0 a bit? What is the best way of doing this? We might have to define any camera. Anyways, this guy is basically moving, but it's moving in a very weird way, right? If you've ever seen the gymnasium ant before, actually the ant also moves in this way. Gymnasium ant B5. And I think we did this like last video or something. Yeah. Sorry, that's an ant. Yeah, if you see how this works, it works pretty. It moves pretty weird. And of course, this ant doesn't have a front or a back, and it's not. We're not using that model, of course, but we're using the same environment, so the same reward function. And I think we could add something on the reward function for it to not walk this way. And like our model here has an actual front, we should be walking facing the front, right? So I think that's part of the reward function. Sorry, I'm trying to zoom out the camera a little bit. Oh. Okay. Let's see if that worked. So there's 3 cameras now. Okay. Yeah. It's still hard to tell which way it's moving. But you can see it's not walking the right way, right? I have no doubt that it's going somewhere. It's not walking away that I'm like, oh yeah, that looks like a real dog, you know. That's not what we want. But I guess I can show forces here. That's interesting. Contact forces. So it looks like this top right feet is barely it's barely touches the ground. That's interesting. Now we're moving that way, it looks like. Up. Anyways, so that's the thing. I'm gonna stop training that, and I'm probably gonna delete these data just because like I need the disk space. Or I'll delete most of it, I guess. I didn't realize it was so heavy. Have a new hard drive coming, and I mean the next step is to load our own file, right? And like I said, this video has been dragging for too long. You know, Christmas, we're right around the corner. It's December 20th. But anyways, I think I think it should be as easy as replacing the XML file to get our stuff running. This scene file, right? So the tutorial might even, because the tutorial even says load a custom quadruped robot environment, right? And it has two files, one scene, XML. None of these really matters, you know. I added a camera. This makes no difference. You can delete that. This is like some visual stuff. Really what matters here is the fact that it's including the Go1 XML, which is basically our MuJoCo file. So this guy here. This structure might feel very familiar because that's basically what we created here. Yeah, it's basically, I think it's the same thing. It's just because it's not an XML, it's not, yeah, there you go. No, it's an XML. In fact, let me try something. Let me just try putting this here and robot XML, and then the scene will call for robot XML instead, right? And if we evaluate this, will our model load? I think the answer is yes. Oh, it's missing the meshes. I'm just gonna paste this as well here. I think the answer is yes. Okay, something exploded there, but you can tell that I don't know what's the error here. What is the error here? You can tell that our model is loaded correctly, right? It's just something else is wrong. Poor model performance. Okay. Well, instead of destroying these, I wanna try to do it properly, right? So and by doing properly, I mean basically we had a quadruped example. I'm going to copy this again and I'm gonna rename this Antarctic example, which is the name of our robot supposedly. And then we copy these here, copy the meshes here. Robot XML. And I know what you're thinking. It's, oh, you're doing the same thing. Actually, I'm not. No, I'm not. What I'm gonna do this time is I'm gonna do a training run. Of course, I don't really. Actually, I guess I should train. I don't really care to train these for, you know, another 10 million. We'll do like a super quick. We'll attempt a super quick train. And see if that works. Appears to be working. 100. So we know we should have something. Sorry, I messed that up. Whoop. Oh, I might have deleted too much. Okay, let's try it again. This is, I mean, it'll be cool if this works. But now I think the next step is to like really understand what inputs and outputs go into training this model. I haven't seen what's in the end observation space on the environment we're using. I haven't seen how you define actuators in our model, right? Right now, the K-scale library did it for us. I think every joint is an actuator, which is obviously not right. And yeah, like I don't know how to do inputs, right? So it's like obviously sometimes you want it to walk forward, so you have to have an input for move the direction. You have had an input for I don't know, maybe the first training run we do is just learn how to stand. Um, let's see if this works. I'm not sure if I understand that error. Let's see if the AI understands. Actually, we can just Google this also. So we might be crashing. I guess one thing that, let's see, what's the reward here? Because we didn't tweak the healthy set range, C range, set height range. And actually I don't know how tall our robot is, so that might just be unrealistic. The reward is very low. And the episode length is very short. And so, I don't know when do we terminate this episode. So let me switch that. I'm not gonna say infinite, gonna say 1. Healthy reward main body. Main body 1. The episode length is very short. Let me see, what was the termination criteria? Terminate when unhealthy. Apparently it's a parameter you can set here. Let's try that. I want to get longer episode lengths just so we can actually see if things are working. That appears to have made no difference. Episode length mean is very low. Ooh, reward function is getting worse. I guess that kind of. Total time steps. Let's see about light. Why are we flying? Alright, definitely some issue here with the textures and stuff. You can see that the robot fell and nothing's happening because I disable termination, so obviously a bad idea. Obviously some issue there with the rendering of the environment of the scene here. I wonder if there is some overlapping here. Checkered, yes there is. Assets, mesh, right, front, visual geom, visual. Ground plane, ground, checkered. I'm gonna try something. see if that works. There's overlapping environment. Oh. Oh. Why do we need visual join? Oh, I see. Let's see if AI can help. Can you remove stuff that overlaps with? The main overlapping elements are related to lighting, visual settings. Yeah, exactly. Let's see if this works. Should be simple. It's just, I don't necessarily know what overlaps. Let's see. Oh, all right. Episode length 3 seconds. Not super long or anything. Where's their environment? Here. Okay. Wait, this can't. Oh, is this? Oh, I thought I changed these. Oh, I must have changed it for this guy here. No. Huh. Yeah, I think this is not good. Well, let's take a look. Something about our initial condition, like on the first step, the robot is upside down. I don't know why. I think it should be 0, just in case, just to be safe. Well, I mean, too late. I was already training, but all right. Let's see if more time steps helped. They did not help. To be fair, it's actually not that many time steps anyway. So reset noise scale, frame escape, max epsilon. Yeah, I mean, let me I guess make some observations. Running our first training pipeline with our own model. Observations. Robot always appears to start upside down. No good sense for set reward healthy set reward number range, I guess range. I have no idea how tall a robot is actually. Let's see what else. Overlapping visual parameters with default MJCF file and mfxml. Robot flies upwards for some reason. I suspect this has to do with ground collision, but unsure. Not clear how many actuators we have, how many sensors we have, or what's in the observation space. So these are kind of like my doubts right now. Yeah. And so, kind of like, I want to look into it. If I'm being completely honest, I think like trying to figure things out while recording and putting it out there for the world is actually kind of like counterintuitive, because if I'm explaining everything I'm doing and recording it, you know, part of me wants to I guess appear smart and be like, yes, what I'm doing makes sense, but that kind of slows you down. So I was thinking like maybe I should just go and do it on my own and then come back when it works, kind of thing. Let me get a drink. also like the idea of recording everything I do, and then I can be like, okay, this is exactly how many work hours it took to get this to work. By the way, we just completed 10,000. Let's see if that made any difference. Obviously I think the answer is no, but you never. I mean, we might as well check. Yeah, I was bad. All right, so if I have this list of observations, obviously, like I think the first thing I would start with is robot always appears to start upside down, right? It's like that's not good. There's too many files named the same thing, and it gets confusing. This is why I need to stop copy pasting stuff. On shape Antarctic example, we have train, we have evaluate. Okay, so here on the evaluation file is when we can turn off these. And then that way when we evaluate, we have more time to observe what's actually going on. Also, the camera doesn't fixate to the objects. Alright, that's another thing. Camera ID 0 is not tracking object. Right? That's okay. Now here, this is where it should be 0 on the train in the Antarctic. So I'm just gonna delete these. I think assets can go too. Pretty sure assets can go too. This goes, this goes, this goes. Delete all of this stuff. Free some disk. Nope, that's not it. Yeah, let's try this. Now, while that runs, let's fix the camera. Let's fix the camera not tracking the thing, right? So this one had a good camera, I think, right? Camera. I think that's all it takes to create a camera. Warp body. Under warp body, put this camera, right? So we go here, warp body. This is warp body. Under root, we put this camera here. I think, and then now we have a camera, right? That's how it works, I think. Was it underbody? Did I put it in the right? Yeah. In my mind, that's how it works. You know, what do you think? Must be right. Oh, we can put a spotlight too. Interesting. Anyways, let's see if that works. All right. Good and bad news. Good news. Dude. Good news. We now have a camera. We can track. What do you think of those physics? Rate physics. Right? Good? Yeah, so now I have a camera that tracks. I actually want to get I want to see if I can get rid of the other camera, the one that doesn't track, because it's useless. Oh, I guess it's on by default or something. Let me see if I can specify here. No, evaluate here. Camera ID 0. It's already 0. Okay. Okay. Camera. Why is it not going to the right camera? Oh, we're still going. I thought I closed it. That's funny. kind of funny, right? Ooh. Try to move it, but I don't think I can apply a force. Okay. Alright, so we fixed this camera issue thing. Okay, close it. Camera ID fixed. Okay. A robot always appears to start upside down. So it's kind of like an AI question here. So, what defines the starting orientation of a robot? What is the root file? What's root? Root. In my file, what is the mesh for root? Just want to see what's the root. Maybe torso, middle section. Okay, yes. Is there a way to freeze the first frame in the environment so I can visually see the starting position, maybe by modifying evaluate pi? Let's see what it has in mind. I just want to see the starting position. I suspect we're doing something wrong. Pause on the first frame. Press enter to start the episode. Nice. That's cool. I like it. Let's try it. Nice. Boom, boom, bam. Boom, bam. Okay. Obviously, starting position is absolute trash, right? Gotta. You can't really see. My face is in your way. Just trust me, it was bad. Yeah, you can't really see it. Yeah, you see. I mean, it starts like upside down basically, and the legs are all messed up. So we need to clean up the starting position. Okay. I'll remove that. Is there a better way of visualizing and modifying the starting position in an Excel file? Yes, there are several tools. Design MuJoCo build and simulate tool. Run MuJoCo package. Pip install MuJoCo. Run MJ viewer scene. Okay, let's try that. Python m MuJoCo viewer robot XML. Let's try that. All right, looks good. Looks good. Not really. Oh, I see. File, quit. I think I know what's wrong. We don't want robot XML, we want scene XML. Did I get that right? I did not get that right. Interesting. When I do, the MuJoCo window opens but nothing loads. Why is that? So in XML file in the current working directory. Is that why? Is that why? Is that why? That's not why. Check your XML paths in your Robotics XML. Compiler, angle, rating. Do I have that? Compiler. Yes. Rating. Meshes, angles. Yep. Raw. Bro, it all exists. Verify file structure. Of course. Check that reference files. I'm not sure why this doesn't work. Okay, drag and drop the file here. Okay, I can do that. Bam. Didn't work. Bam, didn't work. Okay, all right. Different idea then. Different approach. All of that except we don't specify a file. And so now we can just drag and drop. JK, we can drag and drop. Why doesn't that work? Drag and drop. The safe. Oh, of course there's no safe. MuJoCo says drag and drop model file here, but when I do it, it's not responsive. Okay, we're using a small Python script that's more reliable. I don't know if I believe that, but MuJoCo script pi. All right, let's try it. I'm very open-minded, guys. I'll try everything. Python, MuJoCo script pi. I just want my own robot friend. What the hell? What does this mean? Are you telling me MJ Python MuJoCo script pi? Oh, there we go. Okay. Why did that work? I have no clue, but that worked. What is MJ Python? Should I ask that question? Don't ask questions you don't want to know, you know? What is MJ Python? What a good question. MJ Python. Anyways, so this is our starting position. You can see a few things that are perhaps look unhealthy. Perhaps, for example, the body is upside down. The legs are all twisted. I only see two legs. The other two legs are through the body, which, you know, not good. So this is not a good pose. But the good thing is here. Actually, the body is good. It's the legs that need to a little rearrangement. What is MJ Python? To use MJ Python is a wrapper around regular Python. Okay. It's a special Python interpreter that comes with MuJoCo, especially designed to handle graphic user interfaces rendering on Mac OS. How am I supposed to remember that when I run MuJoCo files, I do not use Python, I use MJ Python? I'm not going to remember that. It's just asking for too much. Alright, so in theory I can click a leg here. Nothing happens. Control. Alright, so check out all of the controls we have here. Okay, first of all, it would be nice to name all of these things. So we know, okay, first of all, nothing's moving actually, but print model, screenshot, help, pause update. No, do not pause update. Why is nothing moving? Watch. Okay. Why would I want to save that? Pause, update, PC wait, sensor data. Looks like we have no sensors. Help, yeah, help is good. Let's see. Speed up, free camera, select. Select. I just double clicked. Nothing happened. Very nice. Oh. Control. Controls nothing. Nothing. Nothing is controlling. Nothing's being controlled. Okay. Alright, let's go back to the AI. Alright. So I opened MuJoCo and loaded the XML using the MuJoCo script. But I can't move the joins. Why is that? Let's see if it tells me something useful. My plan is to precisely modify the join positions in MuJoCo and then save these as a new XML. Will that work? Question mark. Alright, it's writing code. Writing a lot of code. Let's see. And now, of course, you gotta remember to use MJ Python. I got the following error. This, I don't know if I'm taking a good path here. It feels a little complicated. I love when it says, it seems like MuJoCo Bureau API has changed. So can you just Google this? Shouldn't we be pulling straight from the official docs? Alright, so we're back in MuJoCo. As far as I can tell, nothing changed. The legs are still all messed up. We have new parts that I've never seen before. The hell is this? I don't know. Yeah. Copy post. How do you? I don't want to know. Why is this grayed out? Join positions are grayed out. Group enabled. Should probably see like a tutorial somewhere. I guess my other question is, can I just do this on Onshape? Is it exporting this way? Because that's like how it's on Onshape. I think the answer is no, but froze, computer froze, everything froze. What's wrong with the computer? I guess I'm pushing it. Let me turn some things off here. I don't know why my camera has frozen. Please come back. Okay. Test. Yes. All right. Perfect. I guess we run out of RAM or something. I don't know. Right? Why can't you just export it like this, like a normal person? Why do you have to export it like all wrecked? All hecked? Yeah, that's basically how it exports. I guess minimum and maximums for the Revolut joints that have minimums and maximums, which I guess it kind of makes sense. Actually, maybe that's kind of like easy to modify here, right? What defines the starting position of, for example, rear right servo box of the body with name rear right servo box. Right, so this is that box here, and I know that starting position is no bueno. This is what the starting position looks like on the rear right. So we need to rotate it 90 degrees. So it should be easy peasy lemon squeezy, but yeah, here, breaking down defense XYZ coordinates. What the hell? I want to rotate these by 90 degrees. What number should I change? And I realized I don't think this is degrees, I think this is radians. To rotate, modify the quaternion value. The current quaternion represents 90 degrees rotation. Okay, what actually changed here? The quaternion. Let's see. Let's try that. I mean, it indeed rotated, just not in the correct axis here. So let's let's try a different axis here. Oh, and the camera has stopped working again. Okay, that's not it either. I guess at least the screen capture is still working. Camera is back. Camera is gone again. My iPhone must be doing things. Okay, that's not it either. It's only one left here, or well, I guess that could be a combination. I'm gonna ask it. Oh, that's not it either. All right. What do the 4 fields in the quad parameter represent? Oh, I guess it told me. Around the x-axis. Oh, I should have just listened. Next question. Alright. What do you think we have defined as the x-axis? If you had to guess. Does it say here? Of course it doesn't say here. Oh, too useful. If it's the same as here, x-axis is left to right. So we want rotation on the y-axis here. So we want the rotation around the y-axis. Let's try that. Let's try. Trial and error here. Just doing some. Oh, okay. Well, no. I mean, no. That wasn't. Sorry, I meant the x-axis. So it must be using different axes. It must be finding the axis different, right? It's the only explanation. Is that bad? Let's do 180 degrees rotation around x-axis. I mean, once we figure out which axis is which, it's easy to fix them all. Okay, alright. Okay, let's just apply logic here, right? Obviously, these two boxes have the same coordinates except in the y-axis, right? So that's how we figure out which one's the y-axis. So rear right servo. So I'm gonna make a note here. And then what is this called? RHS front. RHS front. Right, so there you go. So that's, oh, that's the y-axis, obviously. I guess the question is, when it rotates, where is the axis? Like, because the axis of rotation I want is on the joint. So actually, I guess a better prompt would be rear right. I want to rotate rear right servo box 90 degrees around, and then the joint. Servo hip, DOF servo hip. Where's DOF servo hip? DOF. No. This around the joint. That's what I actually want. Let's see if that works. I mean, but you didn't do it. Another 90 degrees, please. Yeah, nothing changed. Unless I'm modifying the wrong file, which I'm not. Let's see. Nope, nothing changed. Can I change these things using these sliders under joints? It's kind of like very annoying to change stuff on the sliders. When I run MuJoCo script MuJoCo script, these sliders are grayed out. Alright. MuJoCo. Alright, we're gonna change the code here. Honestly, this is a lot of code to do something very simple, which is just visualize in 3D. Which is basic functional. Like, man, come on. It didn't work. Maybe I just Google things. Best way to modify XML MuJoCo file orientation. I can modify XML files from MuJoCo. You can use XML file argument. How can you rotate the orientation of the middle? Yes. I don't know, man. I don't know. Let's see. User interface. Yeah. Let's give these another try. I don't think it's gonna work, but we should be positive. Oh. Didn't work. Yeah, basically, okay, we're so close, so we just need to change the orientation. And the orientation is defined on text files, so it's like, it's really not that hard. MuJoCo NJ option. Dude. Stop it. I want the most basic version of everything. That one worked kind of fine. And then here, what's the functionality you want to use? Model, opt. MuJoCo MJ model. Let's see, MuJoCo MJ model. Oh, MJ model. Enabled position consider position control. Position control. Wow. Man, it shouldn't be hard. I don't think it's that one. I think it's the next one. But that didn't do what I thought it would do. It's interesting. Yeah, I guess nothing's doing what I thought it was gonna do. This is basically already 0. So take it to 1. Change. Oh, interesting. Bro. Let's see how Quartinians work. Maybe I forgot. Bro. Okay, I'm gonna ask O1 Mini. What is the simplest way to rearrange the orientation of different objects in an XML file for MuJoCo? MuJoCo? Thinking. Open XML files. Modify the orientation. Yeah, I tried that. It didn't go well. Using Euler. Oh, that would be great. Euler. But we're not using Euler, so are we? Is there a graphical method of doing this? Blender. You know what? MuJoCo Blender. MuJoCo. Do I have Blender? I do not have Blender. Still on Blender. I mean, if Blender can do this, why can't Onshape do it? Onshape, XML, MuJoCo orientation. Modeling, MuJoCo. MuJoCo can load XML files as well as this. Are the let's see if the URDF files are a little more where did I put that? Here, right? Yes. Are they friendly? Rear, right, servo, box. Limited effort, yeah, whatever. Origin, RPY. Interesting. In URDF, what is the RPY? Origin. Rotation, pitch, roll, yaw. Yeah, I mean, that makes a lot more sense. Except I don't know around what axis. I am trying to understand what axis is the rear, right, servo, box position, and Quartinian defined around. It would be great if it was the join axis, but let me hop in. From the set axis. The Z axis is defined around a joint named DOF shoulder right. What if I want to rotate it another 90 degrees around this same Z axis? That's interesting. This is trying to teach me. You can see it here. Can I see it there? Joint name. Okay, I mean I can't see it per se, but if that's how it works, and then one line here. But then you told me you can modify it. You modify it, and then nothing changes. So I guess okay, something did change this time, but on the wrong axis. That's not the right axis. No. That is not the correct axis. Please try again on a different one, and I'll let you know if it is right. See, it's like doing these kind of things and uploading a video of myself trying to figure it out. That makes me feel like an absolute noob, and I'm like, huh, is this even worth it? That is not the right axis. Let's try a different one, please. Right, this is not the correct approach. The correct approach is using math. The correct approach is figuring out how the axis works, and then going and changing things. But I don't seem to like taking the correct approach. Is it because it's Friday night? It's possible. All right. Okay, let's pretend to want to take the correct approach, right? So this is the body we want to rotate. Let's start a new conversation. What is the position in quad of this body defined around? Is it around a joint? I'm gonna have to leave soon also. It's like getting late here, but so positions are defined relative to its parent body, which is the root body. This for both for position and quaternions. Okay, interesting. If I wanted to adjust, so we've been changing the wrong thing basically. If I wanted to adjust the starting position of a part, what would be the best way of doing that? And I wonder if, I don't think K-Skill had anything for these, but I imagine they also care about these. It's like, you already have MuJoCo. Yeah, MuJoCo. Simulation, simply loading in space. The output of the on-chip is simply a road flow in space. Define an environment within code. More changes are needed to make. I guess that's what they mean by it's not simulation ready. What about the other library that we're looking at? On-shaped robot. This guy here. Gonna give it a star. Documentation. Designing time considerations. Naming links, connecting links, something. Huh. Okay. What if instead of defining the positions this way, wouldn't a better way of defining starting positions be through actuator starting positions, right? Like, isn't that how actuators work basically? Isn't like, don't they act like motors? Look at all these actuators. Actually, no, using actuators to define starting positions wouldn't be the best way. Here's why. Actuators. Do we have a ref attribute for what's a joint that we care? Shoulder, DOF, shoulder, rear, right? Like, why couldn't you tell me this before? Right? It's like, yes, looking at the file. Ref, where's the ref? Ref, okay, 3.14, okay, cool. Radians, 3.14149 times 2, 6, that's 6.28, 318, oh, sorry, my bad, 318. Is everyone happy now? Obviously not, but okay, I'm gonna, like this, oh, I see. I made a typo. Little typo. Okay, let's see if it rotated. Exactly as I thought. It did not care. Why not? Am I even opening the right file? Why is nothing changing? Robotics XML. That's correct. Dude, what the hell? What if it's 0? Bet you like that, huh? 0. Nothing changed. Amazing. So if I change the ref and then execute MuJoCo script pi, then the robot will be starting at a different position. I feel like that's not true. Bro, what? Bro, what? There's no data. There's no data. Whoosh. Let's see. Shoe. CXML. Bamboo. There's one flying. Okay, I guess I kind of get it. The starting position is still suboptimal, right? This is the starting position. Half the robot is through the ground. Not ideal. We can. I guess that's the first thing we can fix. Root position. What is the starting position of root? Position is slightly elevated above the ground. Okay, give me more elevation. Let's see. I don't know. So far, I don't feel like the XML changes to anything. So let's see. Okay. Well, clearly something changed there, so that's good. Okay. Let's run this. A little bit. Why? Oh, I guess, yeah, the issue is there's a lot of internal collisions, which generates forces. Like the leg is going through a torso kind of thing. All right, getting closer to fixing all of this stuff, but the joints that need fixing are exactly the ones in the top assembly, right? So they are named DOF, shoulder, rear, right, for example, and then we have this reference set to 0. Are you sure that the ref field changes the starting position of a joint? The ref attribute is a joint definition. The joint definition actually specifies a reference position for a spring-like behavior. Oh. What? But it seems like there is a starting position implied in the XML file, no? Dude, what the hell? Okay, I guess it's actually pretty normal for AI to change its mind like that, so not a big deal. Yes, you're right, look at the XML file. Join ID, MuJoCo, name ID, chain, shoulder right. I'm curious to try this. It seems like something that's not gonna work and not the right approach. Sorry, or not the right approach, but it might work. Okay, so that definitely rotated. That's interesting. Huh. MuJoCo, shoulder. That wasn't even the right one though. That's not even the, that's the front left. Rear right. Wait, you're telling me that changed because of that? No, right? Oh, it did. Interesting. Dolph shoulder. Rewrite. Interesting. I want to also change the starting position of DOF, shoulder, rear left, front right, and front left. This just feels completely wrong. Okay. All right. So why is it not working? Joint names. Joint name. MuJoCo and Jibra. Okay. Well, even when we had just one, it thinks it's calling the name, but it's not. So it thinks it's calling these, but it's actually calling front left, I think. Yeah, front left. Why is that? We'll have to explore here and then search for MJT objects, types, MJT objects, object joint, posts. Name to ID. Get ID of object with specified name. Returns -1 if ID not found. Let's print the ID just to see what MuJoCo or like what these things the ID is. 7. Thanks, it's a 7. 1, 2, 3, 4, 5, 6, 7. I guess that makes sense actually. What is the ID of? I'm gonna go to the bathroom. I'll be back. Yeah, it is 7 indeed. Okay. So we set the ID. What is QPOS? Data QPOS. Here's another ID. Gear 1, gear 1, gear 1. Maybe something about how joints are defined. Joint reference. For ball joints, continuous safety. MuJoCo XML joint reference. And at the same time, we can also attempt to change it here, set it to 1.57. In theory, in my mind, that should work, but we forgot to, of course, point that out. We use the reference attribute joint. Corresponds to the numeric values of joints and the model is in its initial configuration. In our earliest example, elbow was created at a numeric configuration of 90, but MuJoCo doesn't know that an elbow it is, so by default it treats the joint configuration as having a numeric value of 0. We can override the default behavior and specify the initial configuration corresponds to 90 using the ref attribute of joint. The reference values of all joints are assembled into a vector MJ model QPOS whenever simulation resets. Okay, for both. Okay. Joints. Ref. Am I saying ref wrong? Ref real 0. Only used for slide and hinge joints. What kind of joint do we have? Joint name. What kind of joint are you? What kind of joint is this? Revolut joints. It's kind of like interesting that this is like the AI doesn't have access to this data relative to reference point, or like it's not top of mind. Okay, using the ref attribute joint, okay, the ref attribute only applies to scalar joints, slide and hinge. For ball joints, the quaternion safety for free joints, and the quaternion of floor. What joints does MuJoCo support? Right, you're telling me we are a Revolut joint, free ball hinge. Yeah, so it's a hinge. Okay, so it should work. So our Revolut. Okay, so this should be working. Right, why is ref not changing anything? Show name. Unless something else is overpowering. Ref 1 point. Yeah, that should work. Should we reset? Oh, let's see. I have an idea. Can we reset the robot? I don't know. Should we say robot? Should we reset the simulation when starting it? Before starting it. MuJoCo reset. Good practice, you know. Okay. Didn't do anything. Interesting. Oh. Oh no, that's URDF XML. So this does absolutely nothing, which is very interesting. Let's skip this scene. Let's go straight to robots in case something. Just made it darker. Never mind. All right. So the documentation doesn't match what I'm seeing. MuJoCo joint reference for a hinge joint. If nobody, okay, XML schema, right? MuJoCo ref. Joint acids mesh, no. Joint free body joint, right? Joint has reference. The real 0. The references positions the value corresponds to the initial model configuration. The amount of spatial transformation that J applies at a random equals the current joint. The meaning of these vectors was discussed in this channel. Okay. The reference position or angle of the joint, this attribute is only used for slide and hinge joints. It defines the joint value corresponding to the initial model configuration. Interesting. That's exactly what we're looking for. And I am changing it and nothing is happening. Why is that? What's that, huh? Oh, actually, okay. So it thinks it's happening, but it just looks the same. It says 2 now here. Is this one of those where it is changing, but because it's frozen, it's not changing? Is that what's happening here? I mean, I don't think so, but it's like there. Can we take one single step forward in simulation? I mean, even that wouldn't be great. Like if we're starting at one position and it goes to its default position on the first step, that wouldn't be good. Let's try this. Oh my god. I just hate when it's so dumb. Nope. It is funny that it says joint. Or where is it? Shoulder joint. Shoulder joint is at 2, but it doesn't look like it's at 2. It says 2, I understand, but oh wait, or is that the whole thing that we're defining it? But that's not what the docs made it. This is only used for it defines the joint value corresponding to the initial. Oh, I see. So we cannot rotate it with these. That defines what the initial configuration, what we're gonna call that angle. In XML and MuJoCo, what is the best way of changing the starting angle of a joint, of a hinge joint? Based on MuJoCo, using the reference. My hinge champion using QPost compiler. I guess. No, you cannot use the ref attribute using QPost in the compiler settings. Changing the ref number value for a hinge joint doesn't make the joint physically rotate. It only changes what we define as the starting position. I need to physically rotate the starting position, and that's kind of confusing. That's what I was confused before. Now I get it, but I guess this is, I guess we're back to where we had before. Interesting. So in robot XML, if I wanted to change the starting position of Dove shoulder rear right to 1.5C rad, how would you do it with QPost 0? Let's see if this works. Remember, you can have QPost attributes. I mean, is it just another attribute? QPost. It did get rid of ref why did you get rid of ref? Man, I mean, I'll try it. You know what? I just think that's not how you're supposed to do it. You're not supposed to get rid of ref. Yeah, exactly. You should not have removed ref. Oh, dude, ref is not 0. What are you talking about? Dude, come on. I don't think there's a Q post 0. XML reference. Joint. What about just post? Position of the joint specified for free joint. These attributes. See, why can't the AI tell me this? Why can't cursor tell me this? Why can I Google my way to this, but it just can't tell me this? Include. Is it not? Are you not supposed to have posts? Is this the issue? Yeah, that's the issue. Oh, I see the issue. 001.5. Try that. What do we include? The real 001. What's oh man, I don't know. So, yeah, this seems to make it sound like we could do it. Type class body. Oh, I guess okay. We're on the wrong joint here. Body free joint. Okay, let's try again. Composite joint, body joint here. Oh, there's options. Body joint. There's pose here. Damping margin ref range. Axis class type. Limited group actuator. Position. Alright. I guess that's not supposed to be used as starting position or anything like that. In XML, actually, let me ask ChatGPT. In an XML for MuJoCo, can I specify the starting position of a joint? It's a hinge joint. XML starting position joint. Right. State. Interesting. Okay. Can I add QPOS parameters to these XML to find the starting positions of joints. Interesting that ChatGPT figured this out. It was old mini though, but handling multiple joints. Joint name. Alternative method default. Alternative can define default initial positions for joints using default. Default element specified. However, using the state element is more straightforward. Interesting. Let's see. No, dude. That's definitely not it, dude. Why is this? Why are you so dumb? No offense, mate, but yeah. No, I think the correct the correct way of doing this is to just copy and pasting from ChatGPT onto the cursor. Let's see if this works. Okay. State. I got the following error. Post states, I see. It's funny, cursor does absolutely everything wrong. I mean, I don't want to blame cursor. I understand this is like also my shortcoming because I don't know what I'm doing, but why is it that ChatGPT can figure it out? Oh my god. State. Okay, I'm not even gonna ask cursor because I don't think cursor knows anything. So, state. Yeah, I don't get it. Are you having fun? What is the correct way of stating the starting position of an actuator and a joint in XML? I don't think it's even looking at the URL I sent, so. What do you mean initial? That's not a thing. Word body. Is that a thing? No. It's not a thing. State not a thing either. I already have that. That's not gonna do it, right? I think. Yeah. Are you sure state is a valid element in you know what? Ran out of patience here. XML. There must be some examples, right? Real example. Starting position. Initial position. What's the best way of setting the QPost attribute for joints? And then you search the web or something. QPost 0. QPost 0 is actually the best idea, I think. QPost 0. Keyframe? Really? Keyframe. We don't have keyframe right now. It's down to try it. I don't think anything changed, right? I mean, it didn't crash, so. What about defining the QPost 0 in MuJoCo script? Pi. MuJoCo. It's like flying. Obviously I guess these are random, but I mean, at least one of the legs is correct, I think. Right? Yeah. This one here. Two of them on the back. Okay. Well, so maybe that's the way, right? But on a training run, how do we make sure join positions? I think this approach works fine, but in a RL training run, how would we ensure that we are always starting with the correct positions? Which is the main thing here. I don't want to just work once. Create a reset function that always sets the, okay, so in a reset function So we need a custom reset function. That's fine. Okay, cool. I guess save the initial state, restore it. Okay. Let me write this down. Rotos upside down. Custom reset function. Save initial state and restore at the start of every episode. Right, so DOS shoulder front left. Okay, let's fix the shoulders first. I guess actually set all to 0. Oh, actually, wait, isn't the fastest way Command K? Actually, Command K is like how you do this, right? Set all joint positions to 0. Command K, do it. Accept. Perfecto. Perfect. Okay. Okay. I don't understand. Oh, because we have the root here as well. No, not the root. Who told you can touch a root? Okay. Wow. You're uninformed. You cannot touch a root. Oh, come on, dude. I see. Oh my god. I don't understand why we have both. The starting position of the root should be 10 centimeters from the ground plane upwards. I already tried that. That didn't work. I swear I tried that. That didn't work. See? That did not work. Why did that not work? It's because I thought we had already something here for that. Root. The hoots. 1. 2. Q pose. How about just don't fuck with the air? Just don't touch the root, please. Don't touch the root. How about that? Okay. Anyways, DOF shoulder. I'm gonna fix the shoulders. Okay, all shoulders can be. We can start by rotating all shoulders 90 degrees, and that's not gonna make things worse. Perhaps even will make them better, but not worse. 0, 0, 1, 5, 7, 0, 0, 1.57. Let's see. Okay. That did not do what I wanted it to do. Interesting. The positions, the joint positions do not appear to be acting on the exact names specified. Why could that be? Is there a difference between QPOS and QPOS 0? Okay. 90, 90, 90. Okay. We should be modifying QPOS 0. I don't know what changed, but now things seem to be working. I wasn't paying attention to the changes. Even the root stuff is working now. Okay, apparently there's no QPOS 0. Just made that up. Alright. 0, 0. Rear right. Rear right. This guy. Can we go negative? Rear right. I really hate. Oh my god. Alright, so if 0 is there, 90 degrees, right? It's very easy, 1.57. Is that 90 degrees? Right? I think so. Okay. That wasn't. Was it? Wrong direction? It's not like I can rotate negatively, right? That's not a thing. Can I? Oh, maybe I can. Yeah. Okay. What is Revolut 1? And the iPhone has frozen. Camera doesn't move. Now it moves. Getting signs that I should just stop, I think, for now. When things stop working, that's when you know. You should like just take it slow for now. I don't know why, but now that when I double click an assembly on Onshape, it doesn't. It no longer opens anything. It used to, not anymore. DOF hipcam. DOF. Nope. This servo hip. Yeah, servo hip. DOF servo hip. Yes. Here. Try that. No, doesn't want to open. iPhone doesn't refresh. I think computer's dying, guys. I think computer is dying. It's too much. I think we're gonna do another 1.57. Yeah, that's correct. Okay, and now the last joint for these two needs to rotate to match the other side, and then we have a decent starting position. I don't know if we should be starting touching the ground or not. That's a bit of an unknown. Let's figure out what's the name of that last joint. DOF knee. DOF knee. DOF knee. This is a full 3.14, I think. Kind of like want to make sure we're not breaking the because these joints have a range also. Yeah. And then on the front right, what is this called? Revolut 5. Revolut 5. Oh, there's a couple. 314. Let's try. Not that. And then there's this one. 3. Okay, so that's our initial position, and we could get closer to the ground, I guess. It's actually hard to tell, right? So we can start from there, right? And so now if we actually run the simulation, what happens? Nothing happens, right? It just fall. Yeah. The inertias that are a little wrong, but I don't know. That seems like it's not flagrantly wrong. Okay. So that's where I want to leave it for now. So I think we have a starting position. We've started to cross things from our list here. Robot always starts upside down. This is fixed. We have an idea of what we need to do here next. And after that, I think, yeah, something in here. I think this is fixed already. Fixed question mark. This is fixed also. Not clear how many extra. Yeah, so there's a couple pending things we have here, but overall we're in a good shape. We're almost at a point where we can finally train with our own thing. Like I said, I think the first thing we should train for is standing, which should be pretty easy to train. And I need to figure out how to put. Oh, this iPhone stopped working. I need to figure out how to put inputs. Like a standing at different heights would be great. So I want to look into that, but that'll be the next video. I think this has gone for too long. But anyways, I hope this was entertaining. I hope you learned something. I hope it wasn't too painful to watch. It was very painful on my side. There were, a lot of rookie mistakes. And like I said, I am a bit shocked by the state of robotics in 2024. There's a lot of things that could be smoother, a lot of things that could be easier. I imagine eventually these things will be easier. Like when people say robotics are hard, I didn't think it would be things like, oh, it's hard to export from your CAD package onto your SIM package. I didn't think those would be things that are hard. Of course, I'm sure that's not the hardest, but the fact that those things don't even work, it's not very reassuring. If you think I'm missing something, please let me know. Of course, like I always say, absolute noob here, doing this for the first time, figuring things out, a lot of trial and error. You just watch it live. But other than that, thanks a ton for watching. And next video will probably be after Christmas, so Merry Christmas. And we're getting so close to having a working robot here. It's very exciting. Hope you're excited too.